Hello there.
Don't know what we're doing. Things are about to change, it's evolution. Wait to shake the ground, you feel it moving with the revolution.
The tulips only bloom at midnight.
Sorry, what?
The tulips only bloom at midnight.
Are you talking to
The
me?
tulips only bloom at midnight.
I'm gonna sit on another bench if that's okay.
You don't need a secret code to get better deals on credit. You just need a little help from Experian to improve your credit score. Download the Experian app and check your credit score and report for free today.
It may be umbrella weather, but Yorkshire's reservoir levels are still critically low and takes a lot of rain to refill them. So the hosepipe ban is still in place, and we're asking you to make some simple swaps. Take showers instead of baths, and skip washing the car too. At Yorkshire Water, our leakage inspectors are working night and day to find and fix leaks. Thank you for your help so far. Please carry on saving water, even when it's wet out there. Visit yorkshirewater.com/savewater.
Good evening and welcome everybody. This is Obi-Wan Pez for Simplex Pachinko. We are finishing up tonight our series on Peter Liljedahl's Building Thinking Classrooms with Chapter 15 tying it all together. So, let's see. Edit these last photos we just took here. Hope everybody had a good weekend. I was fairly productive in everything that I did, but then completely burned out for Sunday stream, so I did not hop on last night. I just hung out in Elite Dangerous and hung around other people's streams. Turned out to be understandable because this morning I was also not having it and just like had a massive headache and decided to take an ibuprofen and hope that it just went away, which it did. But I still felt like I was pretty hopeless. Didn't actually get anything done today, so oh well. Suppose that's not true. I did vacuum the entryway. But as I said, not a whole lot got done. There's that. Get those downloaded here. This is ETC 15 1 2 3 Cool. All right. Okay. So then we're going to actually find the correct. There we go. Righto. So to get into it, again, chapter 15 is bringing all the 14 teaching practices together and to try and build that thinking classroom that we've been talking about since the beginning. So as we go through, I'm going to read Peter's words, have commentary about the individual pieces that I had worked on, or that if I have any particular commentary on messages that he sent in, messages that he has stated, then I will state that commentary. So, interesting. Okay. Yep. That's a little weird. Okay. So, Peter says, when I began this journey, my initial thoughts were getting students to think is all about the tasks. If I just had the right tasks, everything else would just follow. Despite my experiences with Jane all those years ago, I still believed that if we want to get students to think, then all we need to do is give them something to think about. I was both right and wrong in this thinking. Yes, if we want students to think, then we need to give them something to engage them and propel them to think, but this is far from enough, as we've seen through all 14 chapters prior. I had highlighted give them something to think about, and written in the margin, this is necessary but not sufficient. Any mathematician would probably be able to at least point that one out. If nothing else in our practice changes, then the thinking tasks will just frustrate the students and aggravate the teacher. So I had also highlighted that and said, lead a horse to water and all that. We also have to create a culture where thinking is not only valued, but also necessitated. We have to build a thinking classroom. If you've been following along with the book, implementing new practices as you learn them, then you have already built a thinking classroom. If, however, you decided to wait until you had finished the book, then the question becomes, where should I start? You cannot start with all of them at the exact same time. This would be an impossible feat, even for the most talented teacher. Even if you could, your students wouldn't be able to adapt to all the changes coming at them at once, and so this transformation would not appear as or feel like a success. But you have to start somewhere. But in this regard, where you start and what you do turns out to matter. That is what this chapter is all about, where to start and what to do next. By the end of the chapter, you will have learned the ideal sequence for implementing the 14 practices to build your thinking classroom, as well as have a clear picture of what it can look like when it's all done. So where to start? This became my next research question. And with this question in hand, I needed a way to try and test what would work. So I offered a variety of professional development sessions to hundreds of teachers in groups of 20 to 40 at a time. And by the way, this is what Zach has been talking about. He still does this. He still does all of these like, how do you make building thinking classrooms work for you? He does these sessions all over the place, and as he said, Mrs. Pye went to one of them as well. Right. So I need to also post thank you to Spotify stuff. Esgot and Neoni, awesome job, and all of you wonderful people at Copyright Free Music, thank you so much. And also, right, the book. I've said this pretty much every time, and I think it bears repeating again and again and again. If you want to get this book, there is the link. It is from Corwin, and it is called Building Thinking Classrooms. The author is Peter Liljedahl. He is from, or at least was from, Simon Fraser University in British Columbia, Canada. If you're interested in the book, if you're interested in getting it, and to help to transform your classroom, then I highly recommend it. It's a great book. If you are just curious about what this is, if you just stumbled on this, if you are a student, if you are a teacher who is not in mathematics and or not interested in curriculum development, then I don't recommend you buy this. Unless you are purchasing it as a present for someone who is interested in curriculum development or is working in mathematics education. It's not going to do you any good. And like I said, it's probably not worth your money to go and seek it out. But like I said, anybody who is doing this as their job, as their profession, and anybody who is doing curriculum development, it might be worth a look, might be worth a read, and you can forward it on to a library and or your local math department. I'm sure that somebody would be very interested. Okay. Peter says, I gave each group a different subset and sequence of thinking classroom practices to implement in their classrooms. I gathered data on what sequences worked and what sequences did not. And as I did with the thinking classroom practices, I adapted what I gave subsequent groups of teachers to try. So, as always, attempt, collect data, iterate. This is not to say I tried every possible sequence or combination, or that the sequences were completely random. From the outset, I knew enough about each practice and how they interacted with each other to know that some had come before others. For example, I knew that flow from Chapter 9 was only possible if students were working vertically from Chapter 3, and was only manageable if students were working in groups, Chapter 2. Such connections between practices helped me avoid some ineffective sequences, but I needed to test the others. What emerged from this experimentation was what I came to call Building Thinking Classrooms Framework, a pseudo-sequential order to follow when implementing the teaching practices. So I have that here. like I said, or like Peter said, this is pseudo-sequential. So things need to be in roughly a similar order to these. I also attempted to start with some of the basic practices and then essentially gave students, in my first semester, I started giving thinking tasks immediately. They were in visibly random groups every day, which for this class was 1 hour and 20 minutes. It worked fine enough. It was also a calculus class, so the students were mature enough that it was going to be just fine. They worked on vertical non-permanent surfaces, or in the case of this particular classroom, the windows. That particular class was difficult to defront because it was very small, and there was a teacher's desk right in the front. But I did attempt to move myself into the middle of the room, get the students working, and try and get them to mobilize their knowledge as we were doing stuff. I did, however, work with this calculus class on essentially having the exact same assessments that we were doing in our previous attempt and for the previous rest of the semester. It was pretty much only like the last 3 weeks of class that I had. So, I mean, really, I should just put the numbers down. Right, this was on the order of, I don't even remember. That plane ticket is still in here somewhere, but unfortunately I don't think I have it. Calendar. This was 2022 November? Yes. Yep. Basically the 21st of November to the 10th of December. So like completely inadequate amount of time to make this work in any way, shape, or form. But it was a good exercise in like attempting to get students who had not been thinking about this particular class in this particular way to attempt to like change things up a bit. It was very much shocking for them. And we attempted to, yeah, we attempted to make it work. Oh, we also did consolidation.
Skybet, Acker freeze.
And I did a terrible job of hints and extension.
From their keeper has put you in front. Don't let a lively winger on a mazy run spoil your bet. Just freeze a winning score and win a leg of your Acker early with Skybet Acker freeze. Skybet for the fans. Minimum 5 selections. Football only. Full-time result market only. Max stake 20 points. Max 3 frees per week. Eligibility
Okay.
restrictions for
But that being said, it was
Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry, we can't hear you. Say that again?
But advertising
exciting,
on Spotify
different,
can help your business turn up the volume. With our easy-to-use ads manager,
rewarding to try and get this to work over this short amount of time. The students were slightly upset.
Learn how Spotify can add more to your mix at ads.spotify.com.
Right? They did not like the interface with standard grading expectations because every time that I would, come up with, or we had one exam and then the final at the end, the standard grading expectations, as we spoke with Peter's issues earlier, and the things that he said in the book were going to be problems. Trying to understand how the grading system worked was not going to happen over this short amount of time anyway. The students had very much the same expectations as they would for a standard class. They were not having it that, like, well, it says that we're going to change up the grading, but we're definitely not doing that for this short amount of time, so therefore we're going to do the exact same thing, the exact same test as we had done before. So they were kind of like, I don't know, are we learning enough in class? And that's part of the problem, is also like you're trying to get this taught, and you have to get through the standard material, and you have to make sure that you finish the material, and you have to make sure that you reach the end of the class in the same amount of time that everybody else does, and so it gets to be challenging. Right, the teaching philosophy. Does not mix well with I mean with students indoctrinated. No, not really. Does not mix well with students used to your other teaching style. Elsewhere in the same semester. Right, like if a student were to have you for 2 different classes, that would be different. But if you change teaching styles at some point in the semester, it's going to be very uncomfortable for just about everybody involved. So generally speaking, you should keep the same style as you've been doing. If you want to experiment a little bit, that's fine, but you can't really go all out with building thinking classrooms unless you do it from the start of a semester. You could, in theory, do like I did here, where you're just doing, here are some thinking tasks, we're going to get through all this stuff, we're going to, you know, try and make up the learning, but you're probably going to need more in terms of having the grade book like all figured out ahead of time for this switch. Whenever it is that you switch, you have to have your grade book in order. Right, if there's one thing that I learned from that first experience there. All right, Peter's data showed that 14 practices cluster into 4 distinct groupings, or what he likes to call the toolkits. So, that is the practices that, and the order in which these toolkits are implemented turned out to actually matter. That is, that the practices in the first toolkit, the thinking tasks, Chapter 1, frequently form visibly random groups, Chapter 2, and the use of non-vertical permanent surfaces, Chapter 3, should have all been implemented within your classroom and working well before you move on to the second toolkit, and so on. In this way, the framework is sequential. The data also showed that within each toolkit, order also plays a role, however, not in the same way that it does between the first toolkit, between the toolkits. In particular, for the first toolkit, all 3 practices need to be implemented simultaneously. Alright, so for Toolkit 1, again, this all needs to be simultaneously implemented. For the second toolkit, there is no optimal order. That is, as long as these practices are implemented after the practices in the first toolkit have been established, and before the practices in the third toolkit, it doesn't really matter in which order you implement these practices. So, establish Toolkit 2 after Toolkit 1 and before Toolkit 3. That's pretty much the only advice he has. Everything else that happens in there, just pretty much whenever it happens, make it happen. Toolkit 3. Nope. Yep. Sorry, there's another thing on 2. The data showed that you can implement Toolkit 2 practices one at a time or concurrently, so literally just all simultaneous at the same time. Pay attention If you are implementing concurrently, pay attention to your own capacities to do so as well as the capacities of your students. Make sure that everybody gets it and make sure that everybody understands how it works before you move on. Regardless, within this toolkit, it is important to establish whatever practices you are implementing before adopting additional practices. The book is written with the practices in order shown in this figure. The third toolkit is best implemented in the order presented. So, toolkit number 3 is optimally implemented in this order. One at a time and not moving on to the next one until the previous one is established. And for the fourth toolkit, where evaluate what you value is in... Yeah, okay. Where evaluate what you value, this particular sequence does not matter. What does matter is that grading based on data occurs after, helping students see where they are and where they're going. Again, make sure each practice is established before moving on. So evaluate what you value. Could be here, or could be here.
Skybet Aka Freeze. If an absolute screamer or a howler from their keeper has put you in front, don't let a lively winger on a mazy run
Again,
score
it does not matter in which order evaluate what you value comes, or where in the order that comes, but
minimum 5 selections, pre-match football only, full-time result market only, max stake £20, max 3 freezes per week, eligibility restrictions and further T&Cs apply, 18+, gambleaware.org.
At QuickFit, we know winter's nearly here, the thermostat battles begin, and you're scraping ice off your windscreen with your credit card. And while it's getting colder, it's a good time
establish them one at a time,
At QuickFit,
and
we'll give your car a free winter safety check. Tires, brakes, battery, all the bits you don't really think about. So while you get winter ready, make sure your car
database grading should be after.
check today at quickfit.com or your local centre. QuickFit, drive away happy every time.
Right. After aiding students understand where they are and where they're going. So, makes it interesting. Because of the idiosyncratic sequences within the toolkits, the framework is pseudo-sequential. In some very specific ways, ordering does matter, and in other ways, it does not. Since the framework has emerged out of the research, I've been fascinated by the structure. Some parts of it make sense, like the fact that fostering autonomy should come before flow. Other things were more mysterious and should have required further investigation to understand. In what follows, you'll read about each toolkit in turn and see why it's made up of those practices, and sometimes the order of the practices that are contained within. Toolkit number 1. To understand the practices that are embedded within the first toolkit, it helps to think about your classroom as a system, and like all systems, it operates with a rhythm of routines, expectations, and patterns that, over time, stabilize and become classroom norms. And in fact, not just the classroom, but each classroom So, they stabilize over time to become classroom norms. Once these norms are established, they are very difficult to change. So this is also one of the reasons that that particular version failed, or at least didn't do what I particularly wanted it to do. Although this was the class that had the student who, the year, like during the year after, to give me this tornado pen, which is really cool. It's just got a whole bunch of math expressions, I guess, equations in some cases, on it. I imagine it's probably physics, but close enough. It's got math on it. It's quite cool. I think he was in my Calc 2 class in one of the next semesters or something like that. When we actually did do this for the whole semester. And he and probably 3 other people who were in the small Calc 1 class became students in the Calc 2 class. And they started helping me out with it because they were like, okay, so we get the basic idea of what you're doing here, so let's make this work with like the larger class. So they were kind of my ins in order to get, I hesitate to say stooges because they weren't, they were sort of in on it, but at the same time it wasn't like they were literally on my side, right? They weren't paid help. They were students just like the rest of them, but they were excited to see where this particular teaching style was going because they saw a little taste of it and they were like, there's something here. Okay, so think of each classroom as a system. Over time, your routines, expectations, and patterns will stabilize to become classroom norms. They're very difficult to change once they do. But this is why you likely prefer to make changes at the beginning of the school year when the norms have yet to be established and are still in flux and are still pliable. Let's not use norm there. So we're doing this as until each practice is established. Norms take a while. Okay. To change the norms, this means that you need to also change the pattern of student behaviors and habits. From systems theory, we know that when we try to change a stable system, the system will defend itself. So Stigler and Hibbert, 1999, state, in a system, all the features reinforce each other. If one feature is changed, the system will rush to repair the damage. When that system is a classroom, those defenses look like students resisting, complaining, and becoming apathetic.
On January 2nd, over 300 people were seriously ill with flu in our local hospitals. That's the equivalent of 10 full wards. So this winter, our best chance of staying well is by getting a quick, simple and free for many people flu vaccination, especially if you're older, pregnant or have a long-term health condition. Children can be super spreaders, so get them vaccinated too. Check your eligibility and find your nearest vaccination centre at letsgetvaccinated.co.uk.
You've read our prospectus, used our website, and seen our ads.
Even worse, sometimes the change you make are not even noticed.
The perfect way to explore all we have to offer. Meet our industry experienced teachers and talk to them about our career focus.
So, for example, if partway through the year you have ever tried to induce journaling in a mathematics classroom, you know it is not well received. Even if the students don't complain about it, the affordances of journaling do not initially live up to the hype. This is not to say that journaling is not good or not worth doing. Journaling has been shown time and time again to be a powerful reflective tool for students, as well as a way to create effective channels of communication between students and the teacher. But it usually doesn't do any of this to begin with. This is because, within a stable system, your students are unlikely to even notice that a change in their behavior is required. To them, journaling just looks like a different kind of homework, which is not a radical enough departure from the norms to warrant a change on their part. The 3 practices in the first toolkit, however, are not like journaling. Putting students in random groups to solve engaging thinking tasks on vertical non-permanent surfaces is enough of a departure from the classroom norms that the students will notice that a change has happened. At the same time, the changes to the classroom routines are radical enough that they overwhelm the student's ability to defend itself, and as a result, the students allow themselves to change and to be different, to deviate from their normative mimicking behaviors, and really begin to actually think. And so the system changes. So our goal here is to overwhelm the defense mechanism both in individuals and also in the classroom. Alright, so students will then allow themselves to change because their defense mechanisms have been overrun, and they're like, okay, well, I guess this is what we're doing now. We will actually be doing this for the rest of the semester, and there's no particular point in trying to say like, oh, can't we just do it like we do in every class? Because no, this isn't like every class now. In the introduction, I told the story of how removing the furniture had a positive impact on students' thinking. Removing furniture, it turned out, was enough of a shock to the system to allow the change to occur. The 3 practices in the first toolkit, thinking tasks, frequently formed visibly random groups, and the use of vertical non-permanent surfaces, when implemented all together, act in the same way. They shock the system, shock the students, and necessitate a different behavior, even if you implement it mid-year. So, that was at least one thing that I did do correctly in this one right here. Right, this was 2022. Okay, by implementing all of Toolkit 1 at the exact time that I got back to school, it was able to shock the students into being like, all right, well, I guess this is what we're doing. And yeah, there were some people who were kind of hesitant and worried about their grade and worried about not having everything look the same way that it was before. But realistically, right, it didn't much matter. It was just that the way that we were doing things was different. It freaked them out. So, as such, the practices in the first toolkit, despite requiring massive changes in teacher practice, are not really at all about the teacher. You'll either implement these thinking practices or not. That's up to you. These 3 practices are all about creating a new set of norms in the room and necessitate systemic change, and with it, change in your students. How we doing? Yeah, we got enough time. So, toolkit number 2. Where the first toolkit is all about student behavior, the second toolkit is all about teaching practice. Right, what did I say up here? Okay, cool. This toolkit requires you to make fundamental changes to the ways in which you do things that are the very fabric of teaching, part of the very fabric of teaching. You'll have to think about when, where, and how to give thinking tasks, which may look very different from how you've given out tasks in the past. At the same time, you need to make conscious and deliberate changes to what kinds of questions you answer and the way in which you answer them. You need to begin the process of fostering the autonomy that will allow students to manage themselves and use the groups around them as a source of hints when they're stuck and extensions when they're done. This alone will require you to mobilize knowledge and be deliberately less helpful.
Skybet Aka Freeze. If an absolute screamer or a howler from their keeper has put you in front, don't let a lively winner on amazing runs.
Something that for many goes against the very foundation of what it means to be a teacher. Also in this toolkit, where you found the first practice that moves from collective doing and knowing on vertical surfaces to individual knowing and doing through offering students a chance to complete check your understanding questions. Although these are seemingly like what are used, we are used to calling homework, do not underestimate the changes you have to make in your own thinking about them. First, you have to give up all control over them. These are an opportunity for your students, and for this reason, doing them is their responsibility, not yours. Finally, you need to defront the classroom. Although seemingly trivial at the outset, the rearrangement of furniture will require you to use the room differently in your teaching. This rearrangement is a less efficient use of space, and therefore you may need to get rid of unnecessary clutter, including excess furniture. You may also be required to move your desk away from the spot in the room the standard spot in the room that students most associate with the front. It will require you to reconsider how you move around and where you stand within the classroom. In our research, we found that if any of these practices were introduced as a first step to build thinking classroom, they were wholly ineffective at changing any behavior whatsoever. Although powerful contributors to student thinking, when introduced on their own, they did not have enough impact to signal that the system needed to change and the student behavior needed to change. Positioned here in the second toolkit, however, these practices serve as a very powerful purpose in fine-tuning the thinking classroom and laying the foundation for the third toolkit. Right, only answer the keep thinking questions. Right, give tasks, standing, early, verbally only. Being deliberately less helpful, we're also mobilizing the knowledge by telling students where to find things. So turn your teacherness into a router rather than a dictionary encyclopedia. So rather than being an extension of the textbook, you should be a router. And check your understanding questions. Right. So, with that, we're going to take our first break. And everybody should get up, stretch, grab something to eat, grab something to drink, whatever it is that you need. We will be back in 3 minutes. Yeah, we'll stop there just for the minute. Make sure that we have enough time to get through 3 and 4 together as a team. Like I said, I hope everybody's having a good time. And we shall return. So, see you in 3.
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. You can make me move. Can make me. No alive, make it last forever. Stop in time, yeah, I'm surrendering. Hold tight, chemicals collide. Hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. Can make me move. You can make me move. Can make me.
At QuickFit, we know winter's nearly here. Everything becomes pumpkin spice flavour, and you're scraping ice off your windscreen with your credit card. And while it's getting colder, it's a good time to check your tyres. At QuickFit, we stock Bridgestone Turanza all-season 6 tyres, guaranteed for 20,000 miles, that actually like rain, snow and ice. So while you get winter ready, make sure your car is too. Book today at quickfit.com or your local centre. QuickFit. Drive away happy every time.
Okay, that's 6 of the ragu and the linguine. Make a move, everyone, please.
The customers are rolling in at Stefano's new restaurant, so he needs another chef. Someone with a cool head and an appetite for success.
More flour in the bechamel, let's go.
Indeed can help him find great people fast.
I need Indeed.
Indeed you do. Because Indeed's hiring platform can help you match with quality candidates immediately. To start hiring, visit Indeed.com/try today.
Alright, welcome back everybody. I had to change the laundry over. Took a couple extra minutes there. Alright. Floor mat's still not working right. Okay. So, with that, we're going to hop back in. We'll do exercise during the next break, or after the next break. Right. So, toolkit 3. Once the practices in the second toolkit have been implemented, you're ready to start creating flow in your classroom. And here's where you'll truly reap the benefits of a thinking classroom. Once students are in flow, they're ready and willing to think about just about anything, including curriculum content. Shocking. It is here you'll earn back all of the time you spent establishing a thinking culture in your classroom as you start moving your students through large amounts of information very quickly. This will require more of you than anything else in building Thinking Classroom's framework. Not only will you need to create sequences of curriculum tasks that allow you to walk students up the flow staircase, you need to manage the flow through asynchronous use of hints and extensions. Your ability to give these tasks verbally will help you with this, as will groups' willingness and ability to manage themselves autonomously. This is the hard toolkit. So this will be right, get the students to establish flow state. And here, maintain that flow state through hints and extensions. So you're going to go through and say, hey, I've got, a certain topic that we're covering. I think the example that we had, and the one that I always come back to, is quadratic equations. So you're going to try to factor quadratic equations and then start changing individually, one at a time, the signs that are between all of the numbers. Some of them are going to have a lot of different factors, and some of them will have very few factors. Ivanio, good evening and welcome. Good to see you. Thanks for the shout out yesterday, and there's one for you. If anybody is interested, go check out Ivan. He's doing science and tech stuff, often talks about philosophy and how to think better within science generally, you know, the sciences. Do you have any particular projects you're working on lately? So when we get... Oh dear. Did I just mess this up? No, it's okay. Yeah, good. You want to write another book? Woo! Neural networks and philosophy. Nice. All right, so when you get students to work on these individual, on these group thinking tasks, and especially when you're talking about like the rich, what do they call it? Yeah, I'm not going to find it that quickly, but the kinds of rich thinking tasks that are offered in the beginning of a math class that are going to get the students to start thinking about something. So, for example, have one here where there is a figure drawn on a board which is very super simple. It is just a square that has a diagonal going from one... Is it a square? Yes. With a line going from one diagonal to the opposite. Yeah, it's a diagonal. Going from one corner to the opposite corner. And then from one of the third corners, we go to the midpoint of the opposite side. I mean, there are two opposite sides, but oh, should work in that case, either one. Yeah, it's equivalent. It's fine. Because it's a square. So, go to the midpoint of one of the two opposite sides of that particular angle, and then that will allow us to come up with a very simple, rich task that gets students to think. And in this particular case, all it's going to take them to do like, it's not going to require calculus. This is something that could be offered in even a geometry or an algebra 1 class. As long as the students are working on this all at the same time, you basically are just... Arg. You kind of get them, again, as a teacher, you want to be a router rather than an encyclopedia. So try and get them to start talking with each other about what they see and any specific questions they might have. And that's going to then allow them to work out the problem without having to refer to you all the time. So the question for that square is, there is going to be a... there are going to be two big triangles. I think the entire actual question is, what is the area of the largest triangle in this figure? Right, so you're given no information other than, again, this is a square. The two of the diagonals are connected, and then a third point, a third corner, vertex, whatever you want to call it, is then connected to the midpoint of one of its opposite sides. I recommend just the top. But that's going to create a large triangle on the bottom, and a small one on the top, and a small one on the side, and then a quadrilateral over on the other side. So, asking just what is the area of... Oops. What is the area of the largest triangle in this figure is a rich task, because it gets them to think about things. They have to start possibly discussing with other students, what does the question even mean? And once they start thinking about what the question means, they could also potentially come up with different answers. Although the number will be the same, some people's assumptions about the figure could be different. So for instance, one person could say that the entire side length is 1 because it's a unit square. It was never said anywhere, but if you just assume that it's a unit square, you're going to get one answer. If you assume that the easiest way to do it is to say each of the halves on the top, because it was drawn, the line was drawn to the midpoint, right? Split it up into 2, and then therefore either of the sides is a distance of 1, and therefore the entire side length of the square is 2. So it would be really interesting to see the sorts of discussions which come up, and then you start asking the students, well, whose answer is right? And both answers are right if you go with a person assumed that the whole length was 1 versus a person assumed that the whole length was 2 and got split up into 2 ones. They're both correct because it never started with a number on there. You just have to say, like, okay, what's the ratio of the area between the largest triangle and the whole square? And then now you can actually compare your two answers together. Whether or not you got the exact same numbers will not matter. You will get the same ratio. Want to just call it side? Exactly. You could just let it be S. Yep. Welcome on in, Walking Stick Library. Hope everything's going alright. Okay. So our third toolkit, again, this is the more difficult one. You have to establish the flow state with the students. You have to maintain it through using hints and extensions. We have to then also consolidate. From the bottom. So here, anybody who is new and hasn't heard about this stuff yet, consolidation from the bottom is basically you are standing in front of the, or not in front, we're defronting the classroom. You're standing in the classroom and you do a gallery walk between all of these groups that you have set up around the room who have been working the entire period on these thinking tasks, which are now curriculum oriented. Once you've done, it was usually like you spend the entire first week just doing thinking tasks, getting the students to like get into the headspace of doing these thinking tasks, and then once you have established this is the norm, you slip in more curriculum tasks. Every day you start with a kind of fun, non-curricular thinking task, and then switch to a curricular task as the groups get done. Consolidation starts with a gallery walk around the room. You basically set aside little chunks that you want to highlight and say, like, this group did this thing. And when you get to that group's work, you ask them. In fact, you don't ask that group, you ask everybody else in the room. Somebody who is not from this group, explain what this group was doing here. So your little cordoned off section of the next step in the work, the next step in the process is, what did you guys do with this? And then they, somebody else now has to interpret what's on the board, reformulate it into what they want to say, and then report on it. And if you get multiple students to do it for any one board, awesome. Especially if there's different understandings that anybody has. Consolidation from the bottom means that rather than starting up here with the task that I give you as like a, oftentimes in a math class, it's like kind of the highest level thing that you got to during the day. You start explaining what we did here at this level. But the problem is that the students who are here are not going to get it. So we have to start all the way at the bottom at something that everybody understands, start getting individual students to explain other groups' work, and then it starts building and building and building and going up and up and up. Eventually everybody, hopefully, understands. Do I loudly slap a yardstick on the table and loudly prompt students for an answer like when you were 10? Whoa. I'm so sorry, Ivan. Yeah, that is not in the in the manual anymore. Good riddance for that nonsense. One of my favorite Roald Dahl books is Danny the Champion of the World. Mostly because of the comeuppance that that particular group of powerful men who definitely did not earn that power, or earned it in a completely different place, or earned it in a completely different context, and definitely should not be teachers. Yeah, he gets a bit of comeuppance. But yeah, my father was left-handed and went to, I don't think he was Catholic, but I think his teacher was. And you know, she went to a Catholic school, and yeah, you already know what I'm doing. So he was like, I don't know, 7. And he's writing like this, and the teacher goes like that, says, that's the devil's hand, you don't write with that hand. So every time he keeps getting slapped on the wrist with the ruler, and he's just like, ah, God. So apparently, my father was always left-handed until that point. So, when I was about 16, I think, I started making it a point of trying to write with my left hand. Did he write anything diabolical? I mean, look, carving runes into your desk and then summoning a demon, you know, just some people don't appreciate it. I mean, what else are you going to use those compasses for, right? And then we also have students write meaningful notes. Now, here's the thing. With meaningful notes, this is not just like, oh, make sure you're copying down something important or whatever. This is the, again, paradigm shift of changing the entire culture of the classroom. When you start talking about notes, one of the recommendations was if you take a standard full sheet of paper, fold it into eighths. So, fold once, fold again, fold again. Now, all the spaces are about this big. You have that much space to write something that you are going to forget in about 3 weeks. Anything that you're going to already remember, because obviously I would remember X, whatever this is, right? I know what a quadratic equation looks like, right? Y equals ax squared plus bx plus c. I know what a quadratic equation looks like. So therefore, I don't need to write it down. Don't write it down. Right? If you're going to remember what it is, don't worry about writing it down. If in 3 weeks you're going to forget, for example, that the way in which to solve a quadratic is going to be either to factor it and then set each of the multiples, set each of the factors equal to 0 and then solve them that way. Great, write that down. If you're okay with that, maybe you're going to forget, maybe one of the students who remembers practically everything is like, well, I don't really have much. The thing that they might write down is how to get from your standard ax squared plus bx plus c into vertex form. So in order to go that way, we have to do completing the square. You should have kept better notes. I mean, I needed to keep better notes. I was the negative example of what he gave here, which is writing down practically everything and just having no real direction in terms of your notes. I was writing down everything just because I was interested in, math in general. I was originally going to be a physics student in university, and I was still doing the same thing in college, where it was pretty much I'm just writing down all the things that I'm writing down all the things I'm going to forget, but I'm also writing down a lot of stuff that I'm just going to remember anyway, and I'm taking up huge amounts of space because it's just everything that the teacher is saying.
To explore all we have to offer, meet our industry experienced teachers and talk to them about our career-focused courses.
And that's more of another thing that really is different about classes these days as well. Everything that's on the board you're going to get. Like, one of you in the class is going to take a picture of what's on the board anyway. But the thing that's gone is all of the things that were said in the class. All of the discussions that went back and forth between people. So most of the time, when I'm doing a lecture-style presentation, I want students to just not worry about the notes for a little bit. Don't write what's on the board. Write down what we're talking about. Write down any of the discussions that we're having in the class. Write down the salient points for the things that I say out loud. Because those are gone unless you have a recorder, and not everyone is allowed to have a recorder everywhere anymore, because you have to either state that there is a student in this class who has a recorder, just to let you all know, or depending on where you are, or I need to have your permission in order to have this student record all the lectures. Taking notes on an outline with question prompts. So he does actually go over that in a part, and the problem is that students don't think about what's there too much. What they're doing is they're looking, if you're giving it to them ahead of time, right, they're looking for the answer to those questions, and that's about it. They're just looking for a checkbox. It's not going to shift your classroom culture at all. It's just going to be like, I just need to get this done. I don't need to think about anything else that's happening. And like, some of the students go to extremes and are just going to pretty much ignore everything until it becomes adjacent to one of the questions that's on the list. And then they'll be like, I need to pay attention for the next 5 minutes, and they'll do that. And then once they've got the answer, they're like, all right, what's the next thing? Cool. All right, I'll come back. Mentally, I'll come back when I hear something that's similar to this. Now, again, those are more extreme cases. A lot of students, again, are just mostly looking to fill in a blank. There could be questions with multiple answers. True. It all depends on what you're teaching, and it all depends on what exactly is happening in the classroom. It all depends on your particular questions. There's all sorts of stuff that can go into it. But, and I guess the other goal that you have to keep in mind is that Peter Liljedahl was attempting to increase the amount and the depth of student thinking. So it's kind of nebulous and it's kind of difficult to think about. Just, oh, that's your goal. Great. How are you going to do that? You know, it's hard to try and alter that. But what he found through doing this research with 400-ish teachers over 15 years was that if you're looking at increasing student thinking, again, quantity and quality, then having these fill-in-the-blank stuff is often, not always, but often, ends up being counterproductive. It's not to say that it's worse than what was already going on. The fill-in-the-blank stuff might actually concentrate some people into doing more thinking than they were, but at the same time, it wasn't optimal for what he was doing. Castle Bravo test. Good evening and welcome. Yeah, things are going pretty well. We are discussing Peter Liljedahl's Building Thinking Classrooms in Mathematics. I've said this before, and I'll say it again. If anybody is interested in the teaching method, in the book, etc., that's where it is. I don't get a kickback or anything. It is a book. And he's done several papers within the Canadian Mathematical Society, or whatever it is that's up there. And there's a bunch of papers that are listed in the back of the book. I will say, right, if you are not interested in mathematics education, interested in new educational practices, and or have somebody in mind who would find this absolutely fascinating, you must buy this for them, don't buy it. Right? It's an awesome book, but it's an awesome book for like math teachers who want to change their particular teaching style, or just want a different perspective, or who knows what. I have said this on other streams, or in the past. My big thing with this was I have been to professional development where almost every single one of these individual teaching practices was suggested. This book is helping bring all of them together into one package and say, like, this is the way we're doing stuff. Maths PhD who does lectures. Nice. Yeah, absolutely. Recommend it to other people. Recommend it to your library. Who knows? People might be interested. It's really cool from my perspective. I went to the American Mathematical Association of Two-Year Colleges, AMATIC, number 48, which was in Toronto, Canada. And when you think American Mathematical Association, oh right, that's in North America as well. Amatic had been doing stuff with Canadians a lot more in the past 10, 15 years. So this was, like I said, Amatic 48 in 2022. So November. It's actually, yeah, we're on the 3rd anniversary of me going to this. So Amatic 51 is probably pretty close to happening. I'm sorry I missed 50. That would have been really cool. um, 6 questions, 6 hours. Whoa. Yeah, so Castle Bravo, the exams that I did at my community college were, generally speaking, somewhere on the order of 15 questions, and I did not give multiple choice unless I specifically said, so this is also under my standard lecture system that I was doing up until this point, give or take. The only reason that I would do multiple choice is if it is a question that is not particularly suited toward writing something, like an extended thing. However, whenever I asked multiple choice questions, it was generally something that they could probably find in the book. It's a literal type question. It would have been something more like definitional, and generally speaking, it would have been wrong. So I would tell them, fill in the blank with whatever is supposed to be there, and then explain to me why that is correct, or why the statement that contains this thing is wrong. And maybe I'm not quite explaining that terribly well, but yeah, doesn't particularly matter. But most of the questions were, just like you see in the textbook. Here is a situation. Here is an individual problem that has a particular topic on it. Try to represent most of the topics elsewhere in the whole exam, and then tell students, solve this thing, or explain this thing, or find this thing. Yeah, common misconception, right. A student says the following. Why is that wrong? I kind of like those. Under the Building Thinking Classrooms paradigm, the exams are actually not events which get you a grade. They are, on the other hand, a data collection device which allows you to go back and check how the students are doing on this particular question. What do they understand? It's an opportunity. Oftentimes, I said this when I was doing this in the last year. Yeah. In 2023, I basically jumped into this and did it for 2 full semesters. The spring was not quite entirely enabled. There was something going on with the grade book that didn't quite work with my head. So it was sort of a hybrid again. Better than the fall when I had 2 weeks to implement it. But did not get implemented 100%. And then there was the fall of 2023 when it was entirely implemented 100% with the gradebook. I did, however, do it wrong, and I will explain that probably next hour. But the Building Thinking Classrooms exams were essentially data collection devices where we left it. So what we did, or what I did, was I said, like, here is something that covers this section. And in fact, do I have... I don't think I have a... I have a rubric. This is from section 14 last week, but nonetheless. This is something for an elementary class. Right, so the topic is repeating patterns, probably 4th grade, maybe, give or take, about 10-year-olds. Identify the core of a repeating pattern. Basic is going to be something that probably is just like A, B, A, B, B, A, B, A, B, A, B, etc. And you have to say, here is what gets repeated over and over and over again. Intermediate would be something that has probably 3 or 4 items in it, and maybe there's another... Actually, I would go for advanced and say if there's 3 or 4 items, some of which may repeat before the whole thing repeats, that would be advanced. Intermediate would probably be 3 or 4 items that repeat, but generally speaking, it's pretty obvious like where they actually repeat. It's just a larger number of things. Transfer a repeating pattern, so fill in the blank with the next sequence or whatever. Or no, that's extend a repeating pattern. I don't know what transfer or repeat... Anyway, it doesn't matter. It's on the next page, I'm sure. But basically, these are what is given as the objectives for this particular class. The students would be able to see an example or a number in the textbook which corresponds to this thing. So they'd be able to just look it up anytime they want. And then, come the exam time, you've already done a whole bunch of these things in the classroom where you've said, hey, show me what this particular repeating pattern is. And you've done this either through observation, that's the O here, a conversation, that's the C, or you've collected something where they have actually written this thing down. So they did it on their own. It may have been part of a group work thing, and when you went over to their group work, you said, hey, who did this one? Great, explain it to me for a second. Observation usually is like you saw them across the room and like, yeah, they did it. Like on their own. Or they were the one leading the group. Yeah. Yeah, so same sort of thing. Yep, but the data that's collected here is a bit different. So rather than being like, yes, you've done it, and here are your grades on every individual thing, but the teacher is trying to collect data and just say, like, has this student shown me that they can do this thing? And if they have done so to a satisfactory level, which is generally speaking 2 checks in a row. Me personally, I wanted at least 2 of the 3 modalities separately represented. So a student should have a conversation with me, and or I should observe them in class doing it, and or they should be able to do it on either a test or whatever else. You know, if I have like a quiz someday, then they'll do that. It could also be that, I have asked them specifically to show me one on the board, and they did it. Again, observation is like minimal contact, whereas a check mark is I have asked you to do something and you did it. The H means that they did it with help. The G means that they did it as a group. The N means that they were unsatisfactorily able, or rather they were just unable to perform whatever it was at that moment. And X is they never tried it for that particular thing. It doesn't mean that it's bad, but you just want to collect as much data as possible in order to make sure that a student is going to show you that they know how to do it. Had a system like this in middle school. Nice. Your teacher may have been using building thinking classroom. No, probably not, but so when the exam times rolls around, I said, oh, we're going to have a question that represents basic, a question that represents intermediate on this particular one. Then the next one, it's basic only. Next one, basic, intermediate. Next one, basic, intermediate, and advanced. And the next one, basic and intermediate. And when I did this over the whole... I mean, if he was creating the book, it wasn't him because he was the researcher, not the teacher. Ayo. Walked into that corner. So anyway, I had a question that represented each and every single one of these things. And then what I did was I said, okay, looking at your rubric, which the students pulled up on their computers that were in front of them, they had pulled up Canvas, which was our, learning management system. And I said, you can look at your rubric, and I want you to show me what you know. So if you have done something at the intermediate level, you do not have to show me the basic level. Just skip it. If you've shown me how to do just the basic level, then maybe you need another data point in basic, but you should move on to intermediate. If you have not shown me basic and you want to try the advanced one for this, fill in the blanks and repeating pattern, you could go for it, but it might be a waste of your time because that's an advanced topic. And if you're not actually to that level, you really shouldn't do it. So this was Canada and parts of the US in 2020 and the previous 15 years, so since 2005. Sweden, yeah, I mean, it could be that it's just similar to that because that's what you all already had. So, Peter Liljedahl is a researcher from British Columbia in Canada. And like I said, he worked with 400 teachers over 15 years. So from 2005 to 2020, roughly speaking, maybe a little bit back from there. Co-working streams? Nice. Yeah, they are often pretty good. I've done a few just because I needed like a break. So I streamed in the middle of the day, which is very odd for me. But made it work. Alright, let's get rid of these here. So, in Toolkit 3, we're consolidating from the bottom. So we go to the easy stuff, and we start sweeping upward to make sure that all of the individual students understand what they're doing at the low level, and then we move up and have somebody else explain the next step up in another one, have somebody else explain the next step up, and at some point, some of those students who are not very confident will start joining in the conversation early because they know that they can get a couple of words in and say like, oh, I recognize how to do this, and they'll start feeling better and more confident about their own abilities, and then they start moving up as well. Writing meaningful notes, again, they're writing something that's about 1/8 of a page. That's the recommendation. You don't have to follow it. And then the idea is that you tell them, I want you to write stuff only that you are going to forget in 3 weeks. So write notes for your future forgetful self. Do not write all of the things that you are going to remember and are just obvious. If you know the quadratic formula because you sing Pop Goes the Weasel to it, you don't need my help, right? You don't need that note. You don't need to write it down. If you're still unconfident about it, then you might forget it in 3 weeks. So maybe write that. But also, like, how to use it is going to be a much more important thing than what it is. On the chatter end, yeah. Well, we appreciate you. Right, so then, where are we? Okay. Not only are you going to need to create sequences of curriculum tasks that you will allow you to walk students up the flow staircase, you need to manage flow through asynchronous use of hints and extensions. That was there. Think deeply about how you consolidate a lesson. As mentioned in Chapter 10, planning for this begins shortly after you begin the flow activities, with the identification of student solutions that you would like to share out at the end. So you have to be looking around the room and making sure that you know where you want to consolidate, and then get those students to box out their work or like recopy their work over in a corner and then box it out so that they don't erase it, and then just go about their business on the rest of the stuff. It also involves you seeding ideas for things that you would like to see emerge somewhere in the room. So, for example, if you would like to have a graph to share out during consolidation and no group has yet produced a graph, you may need to encourage one or more groups to go in this particular direction. So tell them, hey, this is really great. Why don't you all, and again, just because you don't see it around the room, why don't you all create a graph for me? See what you can do about graphing this particular equation. And eventually some other group might come over and be like, hey, what are you guys working on? Oh, that's something we haven't done. We'll do it too. That's part of the autonomy and part of the sharing. What was the wording? Yeah, mobilization of knowledge. Sharing. All right. All this planning and anticipation needs to happen while you're managing flow. For this reason, it's important that you have become comfortable with the asynchronous use of hints and extensions to create and maintain flow before starting to think about simultaneously planning for consolidation. So at that point, doing these things in this particular order, actually, I set it over here, right? Yes, optimally within this order. Asynchronously use extensions to maintain flow, then consolidate from the bottom, then help them write notes. So, like he says here, it's really important you have become comfortable with asynchronous use of hints and extensions before starting to think about planning for consolidation. So, make sure that you can just like practically tell them, oh, hey, you ought to go do this thing. Go check out that group over there. Talk with them about what they're doing, because that seems to be different than what you're doing. Get those hints and extensions going before you worry about consolidation, and you can work on that over the next couple of lessons once you start feeling comfortable with hints and extensions, and remembering like how to get those hints and extensions going. The final practice in the toolkit is meaningful notes, which serve two purposes in the thinking classroom. First is to create a record of learning that has happened, and the more important purpose, however, is to help students reify and transfer their group's thinking into individual understanding. So as a group, they all need to understand how to do something, but then as an individual, they need to learn themselves, for themselves, how to do this particular topic, how to understand the topic as a whole. In this regard, meaningful notes mark, in essence, the transition of the collective consolidation that you manage into an individual record of that consolidation. That you manage. Collective consolidation that you manage into an individual record of that consolidation that the student manages. So it starts putting more and more on the student eventually, without increasing a huge amount of stress on everybody in the room doing it. So whether a record is important for you and your students or not, the reification ought to be. So the taking some sort of abstract concept and making it more concrete. That's reification. The data showed that although meaningful notes could be introduced earlier in the framework, the quality of the meaningful notes is radically improved after you have implemented proper consolidation from the bottom. Again, most of the time in US schools, you start from the top of any particular section, where you say, okay, the students understand because I have taught them up to this level. So therefore, we're going to do another application problem. But a whole bunch of the students are way down here because they don't understand how to apply it. So going over question after question after question at this level is just going to get them to mindlessly copy these notes and be like, oh, I don't know what I'm doing. I don't know what to do here. So consolidation from the bottom, make sure we start at a level where everybody understands, or nearly, and then you slowly move up step by step, going around the room, finding the individual bits of the questions that you left as breadcrumbs throughout the whole thing. I would suggest numbering them. Otherwise, you might forget. Otherwise, you do sometimes, as a teacher, right, just look around the room and be like, okay, 1, 2, 3, 4, I know exactly which students I need, or which groups I need to go to, in what order, right? The problem breaks off here. Now we can go to that one, which is the one that follows this one. You've always used notes differently than that. Yep, diagnosed with ADHD, yeah. Taking notes to focus on the material being described. Never read those notes ever again. Yeah. It can work. Right, then toolkit number 4. Final toolkit in the framework is where all of the assessment occurs. That's not to say that assessment is any less important than anything else, but the problem here the problem here is just that it needs to follow after all of the other stuff. Quite the contrary, the assessment practices are where we see some of the biggest changes in student behavior and student performance. I believe the reason that these practices all ended up in the 4th toolkit is that assessment should be a reflection of teachers' practice, and until this point, your teaching practice has been in flux. Once you have built the thinking classroom through the implementation of the first 3 toolkits, you're ready to start assessing in the 4th using thinking classroom technique. One of the ways to do this is to start evaluating what you value. Through the use of co-constructed 3-column rubrics, the assessment practice not only shows the students what you are valuing and that you value the day-to-day activities in the thinking classroom like perseverance, risk-taking, and collaboration, but it also serves to fine-tune student behaviors around those competencies. So basically what he suggested was create a 3-column rubric that says like, that you get the students to fill out. What did you see today that you thought was maybe not so great? If you can, do a sandwich. What really worked well today? Oh, cool. You guys did this. What would the opposite of that be? This thing? Okay. Where do you think you all were today? Think you were all kind of up here in this range. Awesome. Good job. What did you think didn't work well today? We can come up with 1, 2, 3, 4 different things. And in that, you say, okay, great. Here's the thing that didn't work well. And then you kind of wordsmith it to fit what it, somewhat works. What would you want that to be? Wordsmith it a little bit. Oh, great. You need to, groups were not on task. Cool. If the groups are on task, then that's the opposite. And then you just put a big arrow over the top that says that way. And you print out the next day a little rubric that just has that one or maybe a second one on it that says what you're actually going to evaluate today. And then you go around the room, you evaluate 3 groups, but then all the groups individually, all of the individual groups as a group fill out where they think they fit. So we're on this scale here. Oh, we were here. Okay, we were here today. Oh, here we were here today. When they fill that out, they then hand that in to you. And then you hand back the one that you did for the 3 groups that you actually evaluated. And they get to compare your notes, your comments, as well as your grade for them for the day. Now here's the thing. That can go into like an affect score somewhere. But honestly, it doesn't really count. Just doesn't count for a grade. Because you should be more interested in getting the students to that side of the rubric than you should in making a grade. Oi. Okay. We'll come back to the rest of that after our ad break. So we're going to take 3 minutes. And I'm going to get some water, apparently. Have water. Does it say anything about the practicals of giving a lecture? So in this particular method, there basically is no lecture, and I'll tell you about that in 3 minutes. Thanks for coming, everybody.
They'll be calling me, they'll be calling me royalty. Best to give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty. They say I'm dangerous 'cause I broke all their cages. No, I won't sit and take it. No, no. They left me for dead, I guess I'll never learn. Every time I break, there's just more pain to burn. They'll never, never, never learn. Till the battle's won, till kingdom come. I'll never run. Best to give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty. Best to give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty.
Well, it was short. That's good. Does the book say anything about the practicals of loudness modulation? So, no. Mostly because I very briefly mentioned this. But, yeah, the building thinking classroom style barely does any sort of lecture at all. So, mostly the only time that you actually do lecturing is
our open events are the perfect way to explore all we have to offer. Meet our industry experienced teachers and talk to them about our career focused courses. Tour our first class facilities and see where you could be learning the skills needed to realize your dreams. Plus, our friendly admissions team are on hand to help. You can even
is like for a 5-minute mini lecture before you actually get into the thinking task. So at the beginning of any particular class, you've only got about 5 minutes before the students just lose interest, so you have to get them working on something fairly quickly. Let's see. Stop there, punk. It's probably better. Anyway. So you're going to do maybe a 5-minute mini lecture in order to kind of focus the students on something, but you rarely, and if you've set your class up properly, if you've done your homework over the many different days, over the previous sessions that you've done stuff, then you won't necessarily need to do like a specific lecture on a particular topic. There are a few that required some prep at the beginning, and definitely like some of the things that I had done with students, if I didn't offer them particular you know, like a 5-minute lecture, they were really confused as far as how to do stuff. And like just offering hints was not going to help. Right, so this is an eskrima stick, generally speaking. Eskrima is a martial art from the Philippines, which was developed a few hundred years ago before the Spanish colonization. And it was developed as a tool for the workers to fight back against organized crime. So they had people who were trying to shake them down for money, and they said, no, I'm carrying a machete. So these are generally supposed to be analogs of machetes. During colonization, the Spanish were like, we're really nervous about all these people practicing weaponry, you know, practicing martial arts with machetes. And so they were like, you can't do that anymore. And the Filipino people were like, okay, now we got sticks. Which are really good as club weapons, in addition to being analogs for machetes. So we have a few particular move sets that we do. I haven't been to my Eskrima class in a while because they're on Friday nights now, and we've got other stuff going on Friday nights, so yay. But generally speaking, if we have two Eskrima sticks, we're going to start either here or I guess here on the left side. We have a few, like I said, a few different move sets. We have Sticks to Heaven, which consists of a 45-degree angle strike and a return, followed by another 45-degree angle upward strike, and then we twist, swap with another 45-degree angle strike, and then return. And now we're on the left-hand side in exactly the mirrored position. So then we just continue that. Back here, back over here, back over there, back left. And this can also be done while you're moving. So that's a symbol. Got an electronic drum kit, so don't want to damage that. But good news, the neoprene symbols can take quite a bit of abuse. So, but then we also have the, let's see, we also have a few other movements. So we done a 45-degree angle strike down this way. It starts coming up while this one comes across, and then we return this, and this one does another strike. So that was what I had done here just a little while ago. This, that, this. And then also we have something related to it. We usually do a one of the moves that we practice is coming from a one-handed stance. If we just ignore this one for the moment, coming from a one-handed stance, if we want to do a block, we can come up and over our head without hitting our head. with the machete and block a strike here with a backhand technique, and then abanico, that's the name of it. So it's the fan block. So we start from this closed position, we do an abanico, which is a backhand and forehand combination. And then we do what's called a kadlik, where we twist and drop our hip, and then this goes along for the ride. So from here, drop, right, drop and twist, and then this just kind of goes along. Makes this sort of comma shape in the air. So while we're standing here, again like that, and then oftentimes we do a single strike afterward. Let's see. So instead of doing a full abanico where we do a backhand forehand, we're already at sort of a backhand position, which wouldn't give us a lot of power to do much. So instead what we do is we just go to the forehand up over our head, which is also a little bit of a cheeky strike, as the Yorkshireman that teaches me, Eskrima, says. So we go up and over and into a forehand strike, and then we can do the kadlik. There we go. So we just go into the second half of the abanico, and then we do the kadlik from here. Then we come across here. Wait, hang on. Uh-oh. No, that's right. Yeah, and then we just come across there. And now this one is supposed to be on top. Huh. Oh, right. Okay. So we come from here. We do half abanico. Ah, that's it. Yep. There we go. It's been a few weeks. So we do the half abanico, we do the strike across the middle, and then we do the kadlik. And now we're in the reverse position. So now we can again do half abanico, strike across, and kadlik. And then we're back here again. So we generally speaking do a lot of these things in different combinations. And it allows for the opponent to not know exactly what you're doing, which, just like doing building thinking classrooms, you got to keep your opponents guessing. Except you're not. Oh, that's oil from dinner. Oh. I was roasting some broccoli and sweet potatoes, and unfortunately dropped one of the broccoli, and I was like, no! So I saved it against my shirt, but apparently left a bit of an oil stain. What about university level material? So it is technically out of the scope of this book. However, if you do, it is still possible to do it. I have done this up through differential equations. So, like sophomore level of students. I don't think that it would be too much of a stretch to then keep it going for higher level university. However, at some point, the university students might be like, okay, this is like kid stuff. What are you doing with us? I'd say for people who are already interested in math and love doing math for math's sake, this may not be the optimal way to do it. But for people who are in like a general education math class, absolutely. This is a way better way to do things. So that's the thing, is that it's not a 5-minute lecture to complete everything, because you're not telling the students how to do everything. That's the weird part. So many teachers are like, no, I need to tell my students how to do everything, and that is not how this works. So a standard lecture in this style would be more like, all right, let's get this. All right, a standard lecture would go 1. I hesitate to say lecture, right? Standard class, let's say, standard class quadratic factoring. The first thing that you're doing is a non-curricular thinking task. So I said this earlier, you set up a thing on here that has barely any information. And you don't even write this. You say it out loud. All right, your task is to find the area of the largest triangle in this figure. That is all the information you're given. This is a square. This is a square. The one, you know what, let's properly draw so that we don't mess this up too bad. We have one line that is going from one corner to another, and we have another line that goes from a third corner to the midpoint of the opposite side. All right, now it's obvious which one's the largest triangle, just from drawing it correctly. All right, 2. After about 10 minutes, and it could be 5 minutes if if it's a very short class, or if you just want to get them into their groups and working on things and thinking about stuff. If you see that somebody's getting close, sure, 5 minutes. That's all you got. If 5 minutes are up and nobody's even remotely close, go another 5 and then say, okay, so what are the techniques to solve this? Right? Don't actually get an answer necessarily from anybody. That way you can tell everybody else, take that home and think about it. And a lot of these things don't have to be entirely math related. Like there's a lot of individual rich thinking tasks which are just a little bit of fun. It's a puzzle. It has a little bit of math in it. You know, it doesn't have to be a lot. Okay. Now, after stating this right here, you have 5 minutes. The time is ticking. So, within the next 4 minutes and 30 seconds, you have to tell everybody what the task is. So, like yesterday, right, this is the... Yesterday, we worked on, like defining properties of, oops, quadratic functions. Like what? Right, what do we get? You probably want to say, or you probably want to have like the intercepts, the parent function graph, and transformations. So intercepts includes x and y intercepts.
We know winter's nearly here. Everything becomes pumpkin spice
We
flavour.
probably like went from vertex form and also went to I hate the word standard. By whose standard? General form. Right, this is our y equals a times x minus c squared plus d, but then we have to rename this.
It's about being free at heart. It's about letting go.
Minus h plus k, because the general form is y equals ax squared plus bx plus c. Right? I try to use the vertex form as much as possible because it connects with the parent function graph, y equals x squared, and then doing all of the function transformations on it. So this stuff is y equals a times f of b times the quantity x minus c plus d. Parent function in this case is y equals, or f of x equals, right? F of x equals x squared. Okay, so we're going to say, you know, we're going to elicit some of these responses from the students. Okay, we've got the vertex form, we've got general form. How did you figure out how to get intercepts for the vertex form? Okay, well, this was pretty easy. This was going to be y equals, if we take the intercepts question, right? 0 equals, this is a, x minus h squared plus k, and then x is equal to, we eventually get this is negative k over a square rooted plus h. Right, and this could be plus or minus. Alternatively, We've talked about absolute value in here, so like the absolute value of x minus h is equal to that square root. Or x equals h plus or minus the square root of negative k over a. Okay, we talked about how to get the general form of this thing. Right, 0 equals... when we multiplied all of this out, right, we ended up getting ax squared plus minus 2ahx plus a h squared plus k, and then our b and our c relate to these b and c up here, and then we can show eventually that taking this and this, we end up with the quadratic, right? Y, or x equals b plus or minus the square root b squared negative b minus 4ac. See, I still do it. All over 2a. It's the difference, right? I just correct myself faster these days. Right, if we elicit responses from the students, it shouldn't take more than 2 or 3 minutes. And then we could say, okay, so for today, what we're going to do is we're going to look a little bit deeper at our general form and say, is there a nice way of getting this to factor? And we would have talked in previous sections about doing greatest common factor stuff. So we already know how to do greatest common factor, so we pull something out from every single term. Yeah, so like upper level mathematics is probably not going to do it. But like I said, I've done this through differential equations with the level of maturity of sophomores in college. So so it works pretty well for them. And like I said, when you start getting into the area where students are going to learn the math because they like the math, you don't need this framework. This framework is a little superfluous. But that's not to say that you can't attempt to use it at least a little bit. Second year college of 4. So that's a bachelor's level. Yeah. So in the US, right, we have K through 12. Generally speaking, at kindergarten, you're in, 5 years old. And then 12th grade, you're turning 18 years old during the year at some point. It's Zach, everybody. Good evening and welcome, Zach. How we doing? So in the US, K through 12, again, 5 to 18 is usually the age range that we're looking at. Most people will turn 18 during their 12th grade year at some point or another. And then college breaks into like the 4-year institution is bachelor's degree, and that is going to be, generally speaking, students are 18 to 22 years old. And then masters is plus 2 years. So it's usually right. Bachelor's degree is going to be 4 years, master's going to be 2 years, and then PhD is going to be question mark. Which Dr. Zach figured this one out. Congratulations again. I know it's been already, goodness, 6 months, a year. Yep, this is the piled higher and deeper degree. Kindergarten doesn't really count. Yeah, I mean, that's true. Okay, yep. Gymnasium, yep. I'm slightly, I slightly know the German system, only because we studied it in our German class for like the one semester that I took it in college. X year of, yeah. Yep. And yeah, that's the other thing that can happen, is that apart from college, people can take instead, you know what, let's back that off. People can instead say, okay, either we're going to college for this thing, or we're going to go to like a trade school. And we get a certificate. And that can take any amount of time depending on what trade you're going into. So oftentimes people will go in for like electricians, mechanics, and plumbers, and welders are like the 4 big ones at this point that everybody wants to get into one of these things, because they're, generally speaking, pretty lucrative. Like, you could just basically make your own price, because people have to get these jobs done. High paying for the effort, yeah. And not to say they don't, like, these guys work their rears off most of the time, so because they're in high demand. So they're like, all right, well, I'm going to you know, go work this job that's going to wreck my body for the next 20 years, but I'm going to be able to take care of my kids and put them through school. So right, we also have an associate's college. Which is 2 years, which is an alternative, and then either they can go out to jobs.
You've read our prospectus, browsed our website, and seen our ads. Now it's time to visit
Naturally.
college in real life. Our open events are the perfect way to explore all we have to offer. Meet our industry
Zach's gonna hate me for that one. Or this can go back into one of the other degrees as well. But yeah, that's how most people in the US work. So yeah, for this, right, we're saying that if this is the standard class in quadratic factoring, we do a non-curricular thinking task. We ask for techniques, not answers. It's a puzzle. Think about it. Compare it with others on your time off if you don't finish it. Yesterday we worked on defining properties of quadratic functions. What do we get? Come up with as much of this stuff as you can, or bail and be like, okay, well, we're going to work on factoring. And in this particular case, what we're doing is we're going to see that when we have a trinomial like this, this is going to make it difficult for us to be able to factorize this because it doesn't have a greatest common factor, and it doesn't have anything that we see immediately that we could work with. However, if you look at this from the other perspectives, right? Somebody graph it real quick. What are the zeros for this? Oh, well, we have, or what are the intercepts, right? We have intercepts at x equals, this is -2 and -3. All right, can anybody figure out for me how the 2 and the 3 relate to the numbers that are here? Oh, well, it looks like 2 plus 3 is 5, and 2 times 3 is equal to 6. That's really interesting. Is there some way that we could work with this? And somebody might be able to come up with, well, if we did something... if we did something like having 4 terms instead of 3, then we might be able to do what we had done before in some other part of this class or in a previous class. We do what's called grouping. So x squared plus 2x plus 3x plus 6. If we now group these together, what do you see for, what do you see for these? Oh, look, this is a greatest common factor. What do you think you're able to do here? Somebody else come up with, oh, well, we could take these and this is even too much. This is too much, right? I have revealed too much. So I would say, once I get to this right here, I would stop. Right? Stop as soon as you say, oh, remember that thing we did that was on grouping? Or remember that thing you did in a previous class, which was on, like, factoring by grouping? Cool. Why don't you all try to work that out? Go. Well, that's the other thing, right? Is that in this particular case, you can reach for your calculator in order to graph it. Students won't know immediately how to take a trinomial and graph it on a standard set of axes, unless they go point by point and say, okay, well, it's going to go through 0, 6. It's going to go through 1, 12. Yeah, 1, 12. It's going to go through 2, 4, 14, 20. Right? They're going to go do that. But that's boring. We don't generally do that because we don't want to put in that level of effort into, like, oh, let's create a table of values and get all this. No, forget it. We don't need to do that, especially since you all know how to graph it by doing a table of values. What I would want is that students look at this thing and be like, I don't really want to graph this with a table of values. I know how to do that. Let's go to the calculator, just throw it in there, and get the picture, because that's not what I'm asking for, right? I'm not asking you, do you know how to graph it? I'm asking you, where are the intercepts? This is the fastest way to get them. You plug it into your calculator, you throw it in there, and you look. Oh, look at that. It goes right through -2 and -3. And since it goes through -2 and -3, has this nice little shape over here. Cool. Yep. -2, -3, or -3, -2, like that. Now we can move on and say, what does that look like? Right? What does that look like on this section? Well, 2 and 3, when you add them, you get 5. When you multiply them, you get 6. Cool. What do we do here? Well, it looks like we split that middle term by addition. And then again, from there I say stop, okay? All of you work in your groups. Factor the rest of it. Go. The groups are randomly assigned by cards, usually. So I have a deck of cards that I will pull out like however many students are going to be there today. You know, my estimation. If nobody has said, I'm not going to be here, then I just pull however many I need to for the full set. And I just go around the class and I go, pick a card, any card. Right? I could have shuffled them. They could be completely in order. I mean, you could look at them, right? And when the students have been randomly assigned, they don't have a particular cultural attachment to the people that are in their group, necessarily. So they don't think immediately like, oh, well, that person's going to do all the work, I can just slack off. Or this person's used to me doing all of the work, so therefore, whatever. They don't have to worry about that social hierarchy. The TI model that we have been using at my school is a TI-84. This one's the TI-84 Plus CE. It has a boot time. Like, okay, fine. If you don't want something that has color, my recommendation is the TI-86. And especially you being an engineer. With you being an engineer, TI-86 is probably the best way to go. Yeah, here we go. I have one to hand. It's my favorite. Yeah, I don't have batteries in this one, but the text system allows you to do both uppercase and lowercase. The variable system allows you to type in a variable, like typing it in. Does it have symbolic solving and complex numbers? So probably not. It does have symbolic solving, but it has to be a, generally speaking, fairly easy type problem. It does do complex numbers. Vector and matrix multiplication, yes. I'm not sure how the Inspire did its matrix and vector stuff. I never used them. But it is easy enough. And you can manually type them in, or you can go into the menu and then type in the matrices, or type in the vectors. Well, okay. Vectors you have to manually type. Unless you're just doing your vectors as matrices. It is most definitely not color. It is black and white. A TI-86, the TI-86 has not done, or has not been in production since, like, I don't know, 2010, 2005, I don't know. Yeah, those are instantaneous boots, right? The old TI-83, TI-85, well, don't do the TI-85. The old TI-83, 4, and 6 will all have instantaneous boot times, but they are black and white.
You don't need a secret code to get better deals on credit.
Yeah, the original TI-84. And honestly, most of the stuff that you could do with the 86, you could do with the original 84. 86 just has a better UI. It allows you, once you're used to it, you can type upper and lowercase letters, which like essentially doubles the amount of variables you could potentially have. No, it's more than that, because you could you could alternate. Make it, you know, something with upper and lowercase letters in different places. In terms of variables, it's much more like much more like Python. I hesitate to say that. No, it's your variable does have to start with an uppercase letter, which is a little weird, but whatever. A lot of the stuff that's in it, you do have to know the, like, inline notation. So unlike the 84, which is a plus, a big plus to the 84, a lot of the individual things that I used to have to know inline notation, you actually just hit it and it goes to a menu. And then it asks you all the questions, and then you hit enter and it spits it out in line and then automatically executes it. So that's a nice thing for the 84 over the 86. But the 86 is just my calculator because I grew up on it. I had one from probably 1997 on, and I used it until 2010. I mean, realistically, I used it until 2017, 2018, when my school gifted me this, the 84 color. So they let all of the teachers just have one, and like, you know, congratulations, that's something that we're just gonna do. Just buy all of our teachers TI-84 colors. It was a big line item, I must say. Okay. It is not more powerful, no. But it does have individual things that engineers would like. So there are there's a differential equations mode, so you can actually type in differential equations and then tell it to do numerical analysis, and it will do, I think, Runge-Kutta, I'm not sure, from a particular point, and then it will extend forward, and then it will extend backward as far as it can go. Or at least until it goes off the screen or something like that. I don't remember exactly how it works. It's been a long time. Okay, so if then we go on with this, the next group of the first group of students who comes up and says like, oh, we're done, you do an extension, or calls you over, or you notice that they're done, you walk over to them, you do an extension, and you say, okay, cool, what about x squared plus 5x minus 6? So, like, how does that change stuff? Or actually, this would be a bad idea. Don't do that first. You say like plus 10x plus something less obvious. You know what? Let's go the other way. 48 plus 48, 14x. Okay, and then the next one after that is going to be like, well, what about x squared plus 5x minus 6? And actually, let's go the other way. Let's change that one first. So minus 5x plus 6. Right? Then students are going to realize what you're doing here as you start going through. These are going to be fairly simple examples. Let's not do 14 again. So let's do 48 is going to be like 16x plus 48. So you start grabbing different numbers. The 5 and the 6 is okay. Once they start getting it, right, then you could be like, okay, what about plus 5x minus 6? Now we do the minus 6. This is going to get them to think harder because now they have to realize that, oh, this means that the numbers, when you multiply them, are going to have the opposite sign as each other. They're probably not going to figure out that language, but whatever, it's fine. So they figure out like, oh wait, that's going to be like 2 and negative 3 equals 6, but then 2 plus negative 3 is not equal to 5. So like, what do we do with this? Oh man, well, what else multiplies to 6? What else multiplies to 6? Okay, what about negative? What about the only other option is 1 and 6? Is it... Which one is it then? Is it a negative 1 or is it a negative 6?
Over 300 people were seriously ill with flu in our local hospital.
And then they think, okay, well, they have to add. So a negative 1 plus a positive 6 will get us a positive 5, but a 1 minus 6 will get us a negative 5. Okay, so it's got to be this one here, which then we bring over there. Right? And then we go, okay, what is x squared plus 2x minus 48? And then those students have to figure that out again. Okay, what about x squared minus 2x minus 48? Now we can work on both of them being negative. So once we start bouncing through all of these different examples, we get a gradated step that goes through all of these different examples. If a group is like, okay, look, we did these two, no problem at all. But like, we have no idea what we're doing here, right? Check, check, question marks. Then what you want to do is right, send one of their representatives or all of them to go talk with that group over there who figured it out. Why is that particular question a problem for them? Rather than being the encyclopedia, you are the router. Send them somewhere else. Don't have them just talk with you. If you do want to, you can go up to them and answer a quick question, but you don't want to be helpful. Be intentionally unhelpful. You need to be intentionally unhelpful in order to increase student autonomy. So tell them, hey, that group over there has got something. So why don't you go talk with them and figure out what it is that's the matter with, like, what you're thinking. Sometimes it's just, actually my favorite one to use with this, with 48, my absolute favorite in the entire world is that one. Because they're like, what the F are we doing with this? 19? They do not understand that, yeah, actually 16 and 3 is will multiply to 48. A lot of them, so many students, do not remember or do not know that 16 times 3 is 48. Some people just ask, so what would they ask? So if the answer is, oh, we're trying to find the answer, before you get to this point, the point is to shift the entire culture of the classroom to not being answers based. You can explain how to solve this to the LLM, and it does have LaTeX built in with an explanation. Maybe. But again, the intention of this particular teaching style is not to be answers based, but rather to be concept based. To be like, do you actually understand what's going on here? Rather than, like, finding the answer's cool, but I have 1,000 examples, and if you can't explain it to me, then I don't give you credit. Like, if you're chasing grades, that's the wrong way to think about this class. What's going to get you grades is to be able to show me that you understand. It's like, I do not care. I do not care if you're like, I know how to do it, and you just spit out something that a computer could do. All right, we'll come back in 3 minutes. It probably already started. Anyway, thank you so much, everybody, for coming. And we will be back in 3 minutes. We'll finish. We'll actually finish this, I promise.
Roll up to Betfair Casino and play, prize, pinball for free. Play daily for a chance to win a cheeky cash jackpot of £1,000 or more.
Max 1 play per day. Free spins valid for 2 hours. T's and C's and eligibility criteria apply. 18 plus begambleaware.org.
In 2024, a hangry fan posted, "Why do other countries have better McDonald's menus than ours?" So, we went abroad and heisted some worldwide favourites. The World Menu Heist. 9 of the most wanted McDonald's menu items from around the world. Now in the UK. Until 25th of November from 11 a.m. Fees apply to delivery orders. Price and participation may vary, subject to availability.
Whether you're relaxing at home or out and about, make your music move with you. With Premium, you can download your music
99% of your education before LLMs were a thing. Yeah. So. Yeah, and the intention behind this, I mean, this came out in 2020, so like this was also mostly before language learning models. So, it doesn't have a lot to say on it either, but the point that Peter Liljedahl brings up toward the beginning is that basically this entire method hinges around changing the culture in your classroom. So again, you're not chasing grades, because if you're chasing grades, you're not doing what we are asking you to do. Rather, instead, we want you to chase understanding, because being able to explain something is going to be much more interesting and much more important than just being able to replicate something. Like at the end of the day, at the end of the semester, yeah, you do need to do it for yourself, but the way to get there is by understanding and talking with your peers immediately surrounding you, and be able to explain to them, and then be able to explain to you and to the class how other people think and how their model either works or doesn't work for your understanding. Like what's similar or different, what works, yeah, what's similar or different from your understanding of the process. And just in case anybody hasn't followed Zach somehow, E to the 2I Pi, that's Zach. He's one of our other awesome math streamers. Has been doing programming for... Is it your quiz show, or is this one something new? And if you left, sorry. Well, it is. Oh, you're there. Quiz show and a queue system. Ooh. Queue system. Awesome. I have gotten to the point where I finally downloaded, or rather ripped, I suppose, a whole bunch of audio so that I can use for alerts. So, well, I don't know when I'm going to get that up, but it's it has started. So we will have lurk and unlurk, and certainly a few others. Well, thank you, Castle Bravo. I have, yeah, I have definitely done that for a few other people as well. Oh, wait, no, Zach, gotcha. You can thank Penn. Okay. So in this particular system, again, this is all driven across the room. You don't have to do this. This part right here is just basically you've wound up the toy and you've set it down and now you've let go, right? You just have to make sure that the toy doesn't run into expensive stuff. So, when we work on this, we're getting the students to figure out for themselves how all of this stuff works. As you go around the room, you give them a little poke, and you say, like, how does this work with this particular thing? How does this work with... And not every section is going to be identical to this, but... that's 3, setup. 4, we do the link. We connect the thing that they already know with the thing that they can do to solve the section we're talking about. So here, at the trinomial level, what we're doing is we're showing them something that is not familiar. Right, at least in theory. Now, true, these students, if we're talking like pre-calc level, these students should have seen trinomial factoring in high school. They should have seen trinomial factoring in our developmental classes. So they should know how to do it. But if they don't, what they're doing is we think about it in a slightly different way. Ay. Yes, thank you, Famished, especially since that is how much gin and tonic we have. So we certainly need some hydrate to rehydrate the unhydrate. Hey, I've had an hour. That's insane. Are you serious? I've had an hour to drink it. Or the fact that I like G&T. Is that what's insane? Vodka with pickle juice. You know, it probably would not bother me because I actually do like... I will not drink pickle brine, but, you know, I eat pickles on a regular basis. And I eat, like, pickled... what is it? Olives and jalapenos. Yeah, I have olives and jalapenos in my fridge. So, anyway, at stage 4, we do the link, which is show them something unfamiliar, and then show them that there is a method that they already know how to do. Right? Unfamiliar problem with a familiar connection. And then tell the students that they can go from there on their own. And then what we do is we just say, okay, here's an extension for anybody who finishes it. Give them this next one. Give them the next one. Give them the next one as they keep rolling through it. And eventually, some students may not even come to you. They might say, well, hang on, if we can do this, why not try a different one? And they might come up with their own. Now, anybody who's a fan of Outer Wilds will know that this word right here can be loaded pretty hard.
On January 2nd,
you will want a group to help another group, potentially. But you don't want them to just tell them how to do it, because then the first group or the second group will not understand truly, or they will not be able to replicate it on their own, or the discovery will be spoiled for them. So in this particular case, right, the fact that we have this, oh, this term is going to be added and this term is going to be multiplied in order to get these particular numbers. Like if students just jump to that and be like, here's how you do it. Like the other group's not going to understand it. And it's really important that they try to understand how to make this all work. Be like, okay, when they get to this stage where it's like x squared plus 2x minus 48, they need to understand that 1, right, the signs have to have opposite signs as each other, because when they multiply together, you get a negative number. And when you add the two numbers together, you have to get a positive number, therefore the bigger number needs to be positive. So that is a really important thing that they need to understand by about that point. If they don't, then the next step, they'll probably get it, because it's literally the same problem, just with the middle sign switched. Haven't had a chance to touch it in quite a while. Yeah. It's just like one of the best. So I have been one of the proud evangelizers of Outer Wilds for quite a while. When I finally played Expedition 33, I was like, oh, now I might have to start evangelizing this one too. Expedition 33 is such a good game, and it breaks my heart and smashes me to pieces with a rock. Time and time again. I've now been slightly obsessing watching other people play it, which is how I treated Outer Wilds for quite a while. Kerbal Space Program? Yes. I have played the first one. I'm not very good at it, but I have been able to make rendezvous in orbit, and I have not attempted to get to Moon or therefore anything further. I don't think... Yeah, I just can't quite figure it out. And then when I'm on science, it's like, oh, you're running out of funding. Like, great, thanks. The second one we do not speak of? Oh no! What happened? I mean, clearly you do not like it. Stage 7 is consolidate. So we get other students to explain. Explain what's happening with a particular section. So again, you're going to, during the class, you're going to walk around to every group eventually and start saying like, okay, this section, like this particular problem, for instance, this particular quadratic that you factored, I want you all to save this up in the corner. So like take all the work that you've done all over this huge whiteboard, and what I want you to do is just consolidate it up in this corner and like recopy this particular problem. When they recopy this particular problem, they put a box around it and say, okay, don't erase it. We're going to come back later. Then you go around the group, all of the groups in like a weird pattern intentionally, so that the students should need to take as much walking time as possible to get from one example to the next. Then what you do is you say, okay, who that is not in this group can explain what's going on here? That makes all of them have to look at it and think for a minute and then somebody's going to raise their hand and be able to explain it. You have to ask for people who are not in this group, because if you ask, will someone in the group explain this, what they're going to do is everybody else in the whole room is going to tune out. They're going to be concerned with what they need to say when it's their turn. So instead, you turn it around, you flip it on its head, and you say, anybody who's not in this group, what do you see? And they eventually, again, think about it for a minute. Okay, I got it. This is what I see in this particular section. And they will be able to explain it perfectly well. You consolidate from the bottom, where you go for the super easy thing. It's Super Chicken! 07, Commander. Super Chicken is an Elite Dangerous streamer, has been taking a break lately for doing Navy stuff off in Japan. So, great to see you here. Thank you so much for coming on in. And, just generally speaking, awesome person. So, go ahead and give Super Chicken a follow if you enjoy stories or Elite Dangerous or both. Yeah. What time is it over there? So we consolidate from the bottom, start with the easiest problem that's around the room, and then work your way up and up and up. This way, the students who are not super confident in their mathematical abilities will be able to explain some of the stuff at like the low level. And then as you start moving up, they might start getting more confident and wanting to challenge themselves and start explaining something a little bit higher, and a little bit higher, a little bit higher. A little after 10 a.m. Okay. 9 hours off. Okay. Then when you consolidate from the bottom, after you're done with all the individual groups, you say that what we're going to do now is you're going to get the students to take notes on 1/8 of a page. Only. Oop, nope, that's not an E. They only take notes on the items they're going to forget in about 3 weeks' time. So this is what's called taking notes for your future forgetful self. So, like I said, if you're doing the quadratic factoring and they're like, oh yeah, well, I know how to do all of these ones with like the same sign with the plus in the third position here. This is fine. It's when we move to this stuff, I forget what's going on. What do you want to do? You want to get them the pattern. So all of them are going to think, oh, okay, the pattern is, this is the parity of the signs. Obviously, you're not going to give them that language unless they really understand it, but this tells you whether the signs are same or different. Right? Plus means they have to be the same, and minus means they have to be different. Then, the thing that's attached to the x term is going to tell you what the sign is of the bigger number. So in this case, the sign is the same, and the bigger sign is going to be positive. The signs are the same, and the bigger sign is going to be negative. Signs are the same. The bigger sign is going to be negative. So therefore, both of them are negative in those cases. As we move on here, the signs are different, and the bigger one is positive. Therefore, the smaller one is going to be negative. right? So if they understand that the middle sign, as long as the sign in the front is positive, right? Because that can also be a last weird one. It's like you go, okay, what about negative x squared plus 14x plus 48, right? Just to throw them. You could try this. This would also mess everything up because this is not factorable.
In 2024, a hungry fan posted, why do other countries have better McDonald's menus than ours? We went
This one's not going to be factorable. So if you throw that as like the last thing, and only some of the groups are going to get to it, or you choose to only let it go to the groups that have made it, you know, to a certain level, or have a certain level of understanding. If they're kind of like, well, you know, in this stuff here, I wouldn't bother giving them this one. But if they're like, oh yeah, we got this, no problem, then throw them that last one just for fun, just to see what would happen. Because it will be a monkey wrench that gets shoved in the works. Right? 16 and 3 don't work because when you take out the negative here, this is going to be x squared minus 14x minus 48, and we haven't seen that yet in this list. We haven't seen that combination. And so here, 16 and 3, if they have opposite signs, that's 13. And 12 and 4 is 8. Those are telling me that we have to have numbers that are further separated from each other. The only thing that we have that's further apart than 3 and 16 is going to be 2 and 24, which if they have opposite signs is going to get you 22. So now we have the middle number, according to our list, can only be 22 or 13, which now surround 14, which tells us that this can't be done with nice numbers. So we'd have to then say, okay, well, if they're going to have opposite signs and it's going to be a negative 14, then we can't factor this. It's just not going to work. But this is a good failure state to show students. Especially as the last thing. Right? We have reached a failure state. We can't do anything with this. So now, what do? You're in the middle of consolidation, and you've shown them a failure state. That's a good thing for them to take on their notes. Right? Because some of them might not realize. They might be like, well, if I see a trinomial, clearly I'm going to just factor it. They might not be able to get it. And that's okay. Right? Let's see. 9, if there's time. Right? Do a mini quiz on something from 3 weeks ago. So they test whether their notes are any good. Because what they can do is they're allowed to look at their notes from 3 weeks ago and look at this particular topic and then do this little mini quiz. It is not for a grade. All right, 10. Evaluate. Create a rubric for things that did not go well. So, for instance, if you say, what didn't go well today? And somebody says, well, you know, I felt like my group mates weren't really cooperating or collaborating as much as I wanted them to. You could say, okay, well, cool. What's the opposite of that? Okay, well, obviously groups will collaborate. What we're going to do is create a rubric. Where do you think you all were today? Well, I think we were here. You know, one group says they're over here. One group says they were over here. Another group says they were over here. Really, the linearity is all that matters, right? From this side over to this side. We want groups to move more toward the collaboration side. All right, and then what we do is okay, fine, maybe not tomorrow, but next class. Okay, so if you think something did not go well, you point it out, or just point out things didn't go quite as well as maybe some of you thought. What do you think didn't go well? Try to elicit this response. Get the students to be like, oh, well, take ownership a little bit of what happened in the classroom and how can we make it better. Basically, you just say, or you just ask them, you know, what didn't go well? What did go well? You can also mention and say like, all right, great. I think this is awesome. I agree that you all shared your markers among your group mates very well. This is a thing to keep in mind, like for this particular method. If a particular group is hogging the marker for like one particular person, you want to make sure that everybody in the group has a chance to write stuff on the board, as well as not have to write things and therefore think a little bit more. All right, you don't want really the same person thinking for the group and also writing, because it excludes two people. Ideally, every group has three. Right, 11. If you have outstanding evaluations from previous classes, outstanding rubrics that you hung up on everybody's boards, you ask them, would you please fill out how you think you did today? And then you end up with a distribution somewhat like this, and say, okay, we're going to keep doing this until everybody's on the groups collaborate well side. Teamwork or leadership? It's teamwork. Well, for that particular thing. There is no one leader in the group. So the point is, the entire point of like this entire system is that nobody has time really to create a culture within their individual groups, because tomorrow you will be randomized. So if on any particular day a particular person wants to be sort of in charge, they can do that, but every time that a teacher goes around, they're going to start asking more pointed questions toward other people and not allow one person to dominate the conversation. So like you could have a group leader, but at the same time, the point is to make sure that every single person within the group understands what's going on. And with the randomization and with like this aggressive sharing of the marker, everybody should, in theory, get a chance. So one of the, you'll love this, Super Chicken. One of the things that they do is, so this is Building Thinking Classrooms in Mathematics by Peter Liljedahl. Being a math teacher, I went to a national conference in Toronto. Oops. And they had this guy come up and do a keynote. And when I, like the second I got home, I implemented this in my calculus class. And they were like, what the fuck are you doing? Like, it was just this wild, like, you just changed, like, everything we've been doing the entire semester. And I was like, yep. So, I was only able to implement a few things. So, the first thing that you're supposed to change... here. Toolkit number 1 is simultaneous implementation of. You give rich thinking tasks. So rather than like, here's a problem, do it. It's more like, hey, just out of curiosity, if anybody might be at all interested in this, here's a figure. It's a square. There's a line that goes from one diagonal to the opposite, and a line that goes from one of the other corners to the midpoint of the side. Now, it doesn't matter if it's this side here or that side there. It's the same thing. But the point is, you say out loud, and do not write it on the board, find the area of the largest triangle. Go. And this is a task that everybody in the room could probably do, as long as you're above, like, high school 1. Right? Like, as long as you've had algebra, and maybe even not that, you should be able to do this. And the point is that these randomly assigned groups of 3 are going to then, in their groups, discuss what the method they've kind of latched onto is, and then work on the board with a marker, and then like anybody else have an idea, and they pass the marker around to everybody on the team so that everybody has a chance to think, and everybody has a chance to write, and everybody has a chance to speak their mind. That's the ideal. And yeah, if you weren't here for the earlier context, that's what that is. You know, the idea in this setting is that no student should necessarily think of themselves as the leader. This is supposed to be a collaborative task. It is a little more quote-unquote communist in the way that this is set up. Right? Like, everybody should have ideas, everybody should contribute, everybody should have some ownership in every aspect of what's going on in this task. Right? And then we start working on the actual stuff that we're supposed to do during the day. So, no, that's perfectly fine. So yeah, see teamwork turn into all members only do just enough to get it done. Fair, right? Absolutely fair. But the thing is that when you do this particular setup, when you do this particular, like, this is day 15 of explaining this particular teaching method. So I don't blame you for not having the context. when you go back far enough, all of these individual teaching practices come together such that you have changed the entire classroom structure. There is no end point. So if students get stuff done, like, oh, no, don't feel bad. If students, like, and plenty of other people have just probably stumbled onto this video only, so definitely, like I said, don't feel bad. When you look at the entire setup, right? So, like I said back here, we're giving them thinking tasks. The first one is going to be something that's just kind of a puzzle, just kind of fun. And then the next one after that is going to be a curricular thinking task, so something that's actually related to curriculum. You form visibly random groups, so that was the cards over there. Pick a card, any card. You're in the group with that, that card, whatever you picked. The 6s today. Tomorrow, you pick a different card. You're with the 5s, right? You just picked it. It's random. I shuffled them. You saw me shuffle them. And then I fanned them out. And I didn't, like, sit one out like this and be like, pick a card, any card. Like, it's fair-ish. In that I didn't mess with it. All of your groups are at vertical, non-permanent surfaces. So these are usually whiteboards attached to the wall, and you do your whole thing. Normally, the whiteboards are the big, like, standard size ones, and your group has like a 5-foot section, right? 5 feet's enough to do just about anything. So you all work on your 5-foot section to try and work on these particular thinking tasks. We no longer have a front to the classroom, which is going to kind of focus students' attention over here and think that you're going to be the center of attention. No. I'm now standing in the middle of the room and I'm walking all around the entire time. I am not standing behind my desk ever, ever, ever. The only questions that I answer to students are those that keep them in a thinking state. If they ever ask, like, hey, is this right? I'm not going to answer that question. I will divert, deflect, or literally ignore it. So if they say, am I right? Oftentimes it will be, what do you think? Or show me what you've got. Explain this to me. If they're like, okay, so this is what we've got, and they've explained the whole thing, and I just go, and walk away. That's going to get them to stop asking questions that are going to allow them to just kind of relax and not think and just be like, well, he's going to answer it. So, like, I don't need to do that work. He can do it. Right? Doesn't work like that anymore. You give the thinking task early, standing, and verbally only. This is a wild one. We've talked about it a number of times on stream. If students have a disability and they can't stand for any long period of time or at all, then obviously you accommodate. But generally speaking, if you're just with a general population of students who are fine, with being able to stand for the entire class, you just basically just force them to stand up the entire class. Because, first of all, blood flow is better to your brain when you're standing or walking around or doing stuff like that. If you sit, it just kind of like your whole body relaxes. It's too much. It allows you to enter a relaxed, non-thinking state. You only say it verbally because, one, students don't have anything to refer back to. So they have to now decode what the question was and how they are then answering it. there are students who will say, like, well, I need to have this written down. The problem is that, like, a lot of the students who have decoding problems with verbal tasks also have decoding problems with written tasks, so it's not going to matter anyway. Third, it forces them to then negotiate within the group as far as what the actual question was. So they can write it down. They can write down whatever they want on their board, but you don't write it down as like, here's the question. You can write, like I did over on the other side, you can write the diagram. Absolutely. Have the diagram. Here's the diagram. Why don't you all copy that on your boards, and then the task is find the area of the biggest triangle. After the lesson is done, you give what are called check your understanding questions, because they're not called homework, because one, you don't want to tell them where and when it needs to be done. This is on their terms and for their own benefit. Oftentimes, students have this misconception in standard classes that homework is for the benefit of their teacher to give them grades, which is really sad. So, what you do is you say, these are your check your understanding questions. You work on this, you check your understanding to see if you understand how this all works. By the way, here are all the answers to them. So in my community college, we would have had that in a Canvas course as a document, right? Here is the check your understanding questions for this particular section as like a forum post, basically. And then attached to it is, here are the answers to all of the check your understanding questions. And, by the way, it's not for a grade. And, by the way, I'm going to give you the full solutions in 3 days. And, if anyone's interested, this is a forum post. You can ask any questions you want underneath it, and you all can answer each other's questions. How awesome would that be? Mobilize the knowledge. As the teacher in the classroom, you should not be the encyclopedia. You should not be the textbook. You should instead be the router. Hey, that group over there could probably answer that question. Why don't you go talk with them? It pisses students off so bad the first couple of times you do it. So they're like, but I'm asking you. They're like, no, go talk with them. Use hints and extensions to maintain flow. So we talked about that over here as well. Right. So as students finish stuff, you keep giving them the next task, the next task, the next task. If anybody's getting stuck, you give them a hint. Like, what do you think happens to get us this plus in this particular location? Well, we're multiplying. Okay, so how do you get a plus if you're multiplying? Do you tell them to go ask the person they don't like? Well, this plus means that they have to have, oh, we can get 2 positives to make a positive. Well, is that it? Oh, well, I guess you could get 2 negatives to make a positive. Okay, so how does that relate to this negative here? Oh, well, this one is if you add them. So if you have 2 positives, they add up to a plus. If you have 2 negatives, they're going to add up to a negative. So I guess that means this is going to be okay, we'll figure that out. Great, good job. Yeah, sometimes. Love it. Right. So then... I haven't written anything on this section. Yeah, so use hints and extensions to maintain their flow state. So basically what you want is every group is going to be so into it, they're going to completely lose track of time and just start asking for more questions and start seeking out questions. This is the important one. Seeking out questions. Go look at somebody else's board and be like, we haven't done that one. Let's do that one. Because if they pick a question to go try and they challenge themselves on getting a different question that they don't know, you have succeeded as a teacher. Once class is over, right, once the lesson part is over, you consolidate from the bottom. So we go to the lowest level and we say, okay, this group here, I ask them to save the first question. Okay, can somebody who is not in this group explain what is going on for this particular question? And explain what they wrote. It's not necessarily what you wrote. I want you to explain what they wrote. And so the students have to then read everything that this group wrote. They have to translate it into something that they understand, and then they have to communicate it back out. By doing that and trying to pick a different person for every individual group, it's going to help students like start gain confidence. And especially, like I said, if somebody was at a low level of confidence and then they start working their way up, that's what's going to matter for trying to teach the entire class. It's like, how can we get a student who's way low on their confidence level to start picking up? We consolidate from the bottom. So start at the bottom, work your way up. And then have meaningful notes. So here again, this is not everything that this teacher said. This is not everything that the teacher wrote. This is not everything your group wrote. This is not everything that we talked about as a consolidation group. Instead, what we're doing is you just write down the stuff that is going to matter in 3 weeks that you are going to forget. Right? Just write the stuff that you will forget in 3 weeks. Right? Then we evaluate stuff. So create a rubric on what didn't go well this week. You start asking the groups to come up with this, and then you wordsmith it and put it up and be like, all right, this will be a thing that we do next time. In the next class, you evaluate 3 of those groups. And you say, okay, how did everybody do? Write it on your rubric. They all mark it down. You go to the 3 groups that you picked, and you look at what they evaluated themselves at and what you evaluated them at with comments. And be like, okay, well, I think we're in accordance. We both understand that you did, not well, somewhat well, or really well. And here's what I evaluate you at. You do that for those 3 groups, and then everybody else you just collect. Next class, do it again until everybody is pretty much all the way up at the high end of collaboration or whatever it was that you were evaluating. Once you've done that, don't do it again until you need to. Drop it. Go for something else. Right? So, what didn't go well today? Well, people were hogging the market. All right, cool. So that's going to be a new thing for tomorrow. What didn't go well today? Well, we kind of gave up after a little while. Okay, so let's put that on a thing. So you gave up, right? What's the opposite of giving up? We have perseverance, right? So giving up, arrow, perseverance. Where are we? Evaluate yourselves. Tomorrow we do a more formal evaluation, etc.
Join Sky Vegas online casino, where we offer new players 50
Right.
spins to use in your first 7 days, and 200 more when you
Man, I've gone for almost 3 hours talking about not this last section.
we love a good spin. Sky Vegas, play. It's why we're here. 18 plus free spins loaded on
Okay.
eligible game and eligibility
We'll do the last toolkit. We'll try to get through some of the other stuff. It is almost 2 a.m. and I'm still talking, so people might not be happy with me soon. we'll see how things go. So we'll see you back in 3 minutes, and thanks so much everybody for coming. And yeah, we'll finish this up hopefully within about 20 minutes. So we'll see how it goes. See you in 3. Yep, so 2 a.m. We are we are an American family living in England right now, so we're up in Yorkshire and having a lovely time. Okay, so toolkit 4. Oh, don't I know it? Oh, actually, just to be a pain in the ass, we're definitely doing. Definitely doing AR. I haven't done this in a while, actually. So, this is John Gould's Maine Lingo, a wicked good guide to Yankee vernacular. It is a book that has to do with the Sorry, let me just mark that. Okay. So it's a book that has to do with a particular accent which exists in a location called Down East, Maine. If you know the shape of Maine in the United States, it's roughly speaking like this. It comes down like a diagonal like this. It has this little swoop here, and then it goes up into the upper places with Canada and stuff like that. Down East, Maine is kind of like this whole area here, which includes a town inside the little swoop called Bar Harbor, or Bar Harbor, as those outsiders would say. And so there were two guides named Marshall Dodge and Robert Bryan, who were at Yale together, and they had a classmate who was from Down East who said, oh yeah, there was like, you know, all these guys with the crazy stories that they would tell, and they're like, there is no accent that sounds like, you've got to be making this up. And he's like, no, like if you go up there, you will find out. So they took a break during one of school breaks, and they went up to Down East. They went up to Bar Harbor, and they like just chatted with people, and they were like, oh my god, this guy was telling the truth the whole time. And they said, we need, like, I think one of the old guys kind of lamented that like the younger generations weren't picking up on the storytelling, they weren't picking up on the accent, and like this entire culture is just kind of dying. And they were like, you know what, we ought to bring this to people outside of this area. We ought to like actually go and keep this alive. So Marshall Dodge and Robert Bryan went and wrote a script to what basically became like a radio play that was called Bert and I, or Bert and I. And it became a huge hit, especially among New England types, because we know of the accent, or we've heard it, or our friends speak it, or whatever. And you can actually still hear some of it on YouTube. So if you type in Bert and I, it starts with Virgil, or Virgie, the main character. And he says, you know, Bert and I went down to the dock around 4:30 in the morning to start the Bluebird too. And the entire point is that, like, it's a story that has this wide, sweeping kind of content that goes and talks about, I mean, it's almost a whole lot of nothing, but oftentimes it does have kind of a morality tale, or kind of just a bunch of stuff that happens, and a bunch of outlandish stuff that happens, because a lot of it is like big fish stories. But throughout all of it, there's just this hilarious ridiculousness that exists. And so Robert Bryan and Marshall Dodge brought this thing to life, and it's really pretty cool. So if you do get a chance, Bert and I is a fun fun storytelling experience, and especially if you're from like a rural area, and especially if it's not Down East Maine, like, you might go, oh my god, I've heard stuff like this. So, Castle Bravo, let's see. Let's try to find the thing that is closest to your name. There it is. Tonight's word is casting bread. This refers to making yeast bread at sea or in the woods, as distinguished from making hot biscuits, muffins, johnny cakes, etc. Of several explanations of the term's origin, the most likely one comes from the way Cook worked. He would mix his wet ingredients in a bowl and then cast them into the open flour bowl atop the flour with his hands. He would work in as much flour as the mixture would take up, and then he would cast the dough on his board for kneading. Casting bread. Yeah. It's pretty much anybody from New England who has heard it, it sounds like home. I mean, honestly, because so many of our regional accents are close enough to it that, like, you can see the familial connection. You can see, like, all the little bits, and so many of us can imitate it. Somewhat well, in my case, pretty good, I think.
Download the Experian app and check your credit score and report for free today.
On January 2nd, over 300 people were seriously ill with flu in our local hospitals. That's the equivalent of 10 full wards. So this winter,
Upper Silesia.
staying well is by getting a quick, simple and free for many people flu vaccination, especially if you're older, pregnant, or have a long-term health condition.
The diacritical marks throw me every time because I do not.
Check your eligibility and find your nearest vaccination
We're also American, so like diacritical marks apparently are poisonous to us or something. You can yell at me, but Schlask. On the border with Germany and Czechoslovakia before the war. Yeah. Yeah. That's amazing. Oh, yeah. I can imagine. Active attempts, man. It's definitely happened in the US. The Creole culture was, for a long time, attempted to get stomped out. If you try to sigh, just oh. Voiceless S. Okay, so slask. And then the question of intonation, when do you put the stresses and things like that? Anyway. It kinda. Yep. For my second attempt, I'll take kinda. Okay. So going back to Toolkit 4. Oi. One of the ways to do the assessment in classroom is to start evaluating what you value. We talked about the three column rubrics. The assessment practice not only shows the students what you're valuing on day-to-day activities, but also serves to fine-tune student behaviors around those competencies. Along with the use of assessment to shift student behavior, With these competencies, assessment also affords you the opportunity to shift student behavior vis-a-vis content. So through the use of navigation instruments, we talked about with the big rubrics, with the check marks and the H's and all sorts of stuff like that. Okay. That's fair. Able to decrypt the mysteries around content and clearly communicate to students not only the demarcations between outcomes, but also to what level they have demonstrated the attainment of those outcomes. Clarity of this information allows students to focus and take greater responsibility for their own learning. And that's another thing that kind of relates to what we were talking about upstream there. Right, the students will eventually start taking a greater responsibility for their learning and be like, okay, I need to demonstrate this today. So I need to grab that marker and I need to demonstrate for Mr. Obi here that I need to figure out how to do this. Once students are comfortable using these navigation instruments for data-driven self-assessment, you're ready to seamlessly use similar structures to collect and analyze data to track student performance, making the paradigm shift to outcomes-based assessment rather than, again, grades gathering, point gathering assessment will allow you to gather and record data not only from test sources, but also from observational and conversational sources. So both individual and collaborative. So right? Your grades are from data and understanding, not from performance. You don't have to perform. Right, navigation instruments, so we use the rubrics for student behavior. And we use assessment tools to guide students' understanding of where they are and where they need to be. All right, transferring collective synergy into individual knowing and doing. So early on in the research, we came to a troubling realization. This was back when we were mostly exploring students working on thinking tasks in random groups on vertical surfaces and fine-tuning that work with how we were giving tasks, answering questions, and using hints and extensions to maintain flow. The research was far from finished at this point, but things were still going well. Our use of flow was still allowing us to move through huge amounts of content in a very short amount of time. So this is also something that happens here, is that once you start getting into flow, which, you know, takes weeks to get there, the speed at which the content will then move is much faster. So this right here, what we were talking about, this pile is far less than one class. Or at least this would be appropriate to like a 50-minute class in a high school. If I have an hour 20 in my classes in community college, I'd be able to work through this. I'd probably also extend this to include values where A is not 1. So we'd include where you've got like a 2 out front or something like that. So we would also include those on the end of this. So what would happen if we made it 2x squared minus 5x or plus 5x plus 3 instead of 1x squared minus plus 5x plus 6? Hey, how is that similar or different to the thing up there? It might require a stopping point in the middle, and if you do that, then you're going to have to, if it's more than, if your class is about 2 hours, you probably should re-randomize in the middle, but a lot of people are going to find that to be a huge pain in the rear. So, up to you how you want to do it. This also, with the passing of cards and stuff like that, really made me nervous right after COVID. So, basically, I would have all the students grab one of the wipes that was in the middle of the room and like just clean off their whiteboard markers and clear off their cards before handing them back in. Or when they pick them up. Either way, I don't care. We were given lots of alcohol wipes, so I did not care how many they were using. Oh, interesting fact. My community college just sent out a letter of no confidence vis-a-vis our president. Yay. I don't work there anymore, but like I still feel kind of a sense of ownership over the college itself, and like this is an interesting development. I kind of figured this was coming before we left, and it's happened. Okay. So, use of flow was still moving huge amounts of content in a very short amount of time. The problem we realized was that we were not seeing any improvement in students' individual performances on tests. So they would still do the exams at some point and be like, hey, these are opportunities for you to show off what you know. And it was about the same as always. Ouch. We knew that there was likely a disconnect somewhere. I mean, right, check the power cord. And we had to figure out where it was happening. When we looked closely at groups working on whiteboards, what we saw were students working collaboratively and clearly demonstrating and understanding the concept at hand, both collectively and individually. That is, we saw and heard individual members of groups clearly articulating and explaining their thinking in the moment. For example, when we look closely at grade 10 students factoring quadratics according to the flow sequence that we showed up above, what we saw was that in that moment, every single member of the group was able to factor 8x squared minus 8x minus 6 and clearly explain what they were doing. Yet when we tested the students 4 days later, about 70% of the students were not able to factor that, well, a similar quadratic. Somehow the knowing and doing that we were seeing in collaborative groups was dissipating and not transferring to individual knowing and doing. The learning we were seeing in the groups was real, but it was synergistic, temporal, and contextual, existing only in the moment, in that context, within that collective. The individual understanding was that was being demonstrated in those moments was not in fact individual at all. It was only individual expressions of the knowing and doing that was held collectively in memory, essentially. What we needed to figure out was how to transform that synergistic collective knowing and doing into individual knowing and doing. At the time, we had no idea how to do this, But amazingly, over time, with the emergence of additional optimal thinking practices, the issue resolved itself, largely. And with the emergence of the rest of the Building Thinking Classrooms framework, this pseudo-sequential implementation schedule, the final pieces fell into place. Turns out there are 4 thinking practices that work together to achieve transfer from collective to individual understanding. And at the time we were beginning to see the transference issue, none of these were being experimented with yet, at all. They are consolidation from the bottom, meaningful notes, check your understanding questions, and helping students to see where they are and where they're going, or where they need to be. On their own and in concert, each of these contributes to transforming synergistic collective understanding into individual understanding. Consolidation from the bottom helps to name and formalize the synergistic experiences of the collaborative work, but this is still a form of collective consolidation. Meaningful notes provide students with the first individual opportunity to consolidate the collective learning from the group and the teacher's consolidation, and extract it from their personal learning. Check your understanding questions offer them an immediate opportunity to confirm this learning. Finally, helping students see where they are and where they're going offers ongoing and delayed formative feedback that positions this learning within the scope of the unit of study. That is number 2? Yeah. Although each of the individual practices helps in some way to move collective toward individual learning, they're most effective when all 4 work together. As with many things in Building Thinking Classrooms framework, in this regard, the order matters, but not in the same way it mattered up until now. In this case, the order that matters is the order in which the first 3 of the practices, consolidation, meaningful notes, and check your understanding questions, occur within a single lesson. So, begin the lesson by giving a task verbally with the students standing around you somewhere in the room, and they all work individually, or they all work in groups around the vertical non-permanent surfaces. You manage the flow in the room by giving hints and extensions while at the same time planning for consolidation. You keep the students in flow until the energy wanes, at which point you consolidate from the bottom. This is followed by meaningful notes. Finally, you provide the opportunity to do the check your understanding questions within the classroom. So, the suggestion is actually here. Right? Give the thinking task at the beginning. It's 5 minutes. Do the whole lesson within your large section of class. Take 8 to 10 minutes to consolidate and 8 to 10 minutes for students to take notes. And then whatever time you've got left, do check your understanding questions. So whatever this translates to, that's how much time you have. So if we go for a long, like the long time here, right? So this is going to be 25 minutes. Let's say you've got 10 here. That's 35. If you have a 50-minute class, you've got 15 minutes to do the main section of the lecture. If you have a 120-minute class, which realistically my classes were 110. Right? We would do 5 for the thinking task. We would do 20 minutes for the first activity, 10 minutes for consolidation, 10 minutes for notes. This is 20, 30, 45. $55. That's half. Yep, cool. All right, and then we go again. And transfer that first 5 from the thinking task into the check your understanding questions at the end. Or 25-10. However it's going to work. So, block scheduling, right? 110 minutes, give or take. The sequence and pacing works well if the lessons are at least 65 minutes long. I've got 15 here, or 50 here. But, yeah. He says if you go for 65, then that's going to be basically 25 there. If they're shorter, you may struggle to fit everything in one lesson. If they're longer, you may wish to spread things out over 2 days. In this situation, day 1 would be dedicated to having students work in flow and may or may not end with consolidation. In day 2, you'd start with a brief statement of the task and reemergence within flow, except for a shorter period of time, and then moving through the sequence of tasks in bigger jumps, followed by consolidation, if it was done on day 1. Meaningful notes, check your understanding, followed by consolidation, even if it was done on day 1. Meaningful notes, check your understanding questions. Sequence is flexible, can take on different configurations, all up to you. And there is one additional thing about these 4 practices. They're not just about transferring collective synergy to individual understanding, they're also transferring responsibility of teaching into responsibility for learning. In essence, the only difference between homework and check your understanding questions is a shift of responsibility. This is why the practice appears first of the 3 responsibility practices and is only one of the first 3. Nope. It is the only one of the 3 to be included in the second toolkit. So check your understanding questions is way back up there in the second toolkit. Meaningful notes comes next in the third toolkit, requires more responsibility on the part of the students, and is a bigger departure from what they're familiar with. Students are used to being told exactly what to write down in their notes. In normative settings, note-taking is more akin to scribing what is written on boards. This requires little to no thinking and little to no ownership over what gets written down. Meaningful notes is a massive departure from the passive activity. Not only do students now have to extract their own meaning from their collaborative activity and the teacher's consolidation, they also have to choose how to sequence and represent the meaning. They have to take ownership over the production in the moment and its use in the future. Understanding where they are and where they're going comes last in the fourth toolkit. This practice requires the most responsibility, and it is a call for students to completely own their own learning. Although the teacher creates the structures to do this, the students ultimately have to monitor and track their own learning and take action when they see that they are not attaining an outcome at whatever complexity level they need. Each of these student responsibility practices is offered as an opportunity to students in a thinking classroom. And, as opportunities, they're sensitive to teacher meddling. That is, if a teacher makes motions to require students to take on this responsibility through grading or punitive measurements, then they transform the responsibility practices back to accountability practices rather than responsibility. And then we're right back to the students doing them for the wrong reason, for grades, and for the wrong person for the teacher. I believe it's because of this sensitivity and the hierarchical increase in responsibility within these three practices that they have been distributed within Building Thinking Classrooms framework the way that they have. One each in order of required responsibility in the second, third, and fourth toolkits. And I also believe that this is why there are no student responsibility practices in the first toolkit, which is about establishing collaborative thinking culture more than facilitating individual knowing and doing. Right. All right, it being almost 2:30, I'm just gonna stop. Tell you what, on Wednesday, I think we're gonna finish this, and we'll just do the last little bit as part of our what's normally a calculation night. So stream's gone on long enough. I should have planned a little extra more time, but yeah, it's a long chapter, and then we got off on a few different tangents. So thanks. I don't mean that sarcastically. Thank you so much for everybody being here and contributing and talking and chatting and stuff like that, because it's, you know, keeping everything busy and moving, and sometimes having a little diversion to just relax a bit. Awesome stream. So we're gonna, if you want the devil to laugh, show him your plans. Yeah, well. Okay, we're gonna go over and see Penn Center, who is currently working on SVM in R. I'm not entirely sure what that is, but we'll go see. So I hope everybody has a good day. We'll be back tomorrow with 9 Souls and do some more totally comfy, cozy Tai Chi Kitty. Definitely, 100%. Not at all Hollow Knight. And then we'll go and check out on Wednesday. We'll be back and do some calculation stuff. We'll finish up Building Thinking Classrooms and then be back. And then probably after the first break, we'll do cracking the GRE. So if anybody has any questions on mathematics type stuff, please ask. Let me know. Yes, yeah, R was made for stats. Yep. And Penn knows it way better than I do. And then next Monday, we're still planning on having Zach, E to the 2i Pi, come on over here, and then we'll be doing a collab stream on Building Thinking Classrooms, how it implements well, how it might need some work, all sorts of stuff. So we'll have a good discussion, and hopefully see you all then. My name's Obi-Wan Pez. This is Ensign Blake Spachenko. We'll see you next time. Thanks so much for coming.